Welcome back. We are COMP1116, that's Game Programming 3 in the fall 2025 semester at Georgian, and it's week 3, part 2 of our broadcast and recording together. And let me just have a little bit of the nectar of the gods. Hold on a second here. Diesel fuel, of course, black is the way to go. So previously to this video, we had a bit of issues. How did I fix it? I rebuilt everything, but one thing that if you're working on the school computer, what I had to do, and I talked about here in the class, is I had to actually remove. Let's kind of do that here a second. Let me open up this cloud paging player. I literally had to shut down and remove, like actually click this button, remove Georgian Epic Games Fall 25, remove it after I reboot it, and then bring it back, like actually go to Apps Anywhere. And the way you would find that is you just go to Apps. You can actually search for Apps Anywhere on your machine. This is what I did for the people who are going to have this problem in the future. If you try this from here, search for Unreal here. That's what I did, just so that way you can see it here. Launch it again. And then what this did is it brought everything back to its current state. Okay, so that's where we are right now. So that's a good thing and a bad thing. So the problems I've been encountering are not Unreal Engine specific. They are not Visual Studio specific. They are school specific. Right? This is the way this thing has been installed. Unfortunately, with lack of admin rights, and also some files are locked, we may have to, if we have to add anything here again shortly, we'll have to do that. Okay, but back to here. So what we were talking about before we left was this idea of let's navigate to the content, assets, characters, arms, arm animations folder. Let's do that. So if I go back to Unreal Engine now that I have open, I can do that. I can go to assets, characters, I believe, arms animations, and you can see all the animations here. So these are all the animation sequences that you have that are built into our little project that I gave you. Okay, so I've given you a bunch of assets. Here they are. What we want to do is we want to create a montage, right? And I'll talk about what that is in a second. So these are the ones we have. Eventually we'll be using arms idle, arms walk. These are all the animation sequences we're going to be using. But what we want to do is we want to create animation montages. So again, if I go back to the documentation, I kind of put that in the link too. What is an animation montage? Well, where I have multiple animations, take a look here. I have multiple animations here. For example, this one is shotgun reload drop, shotgun reload load, and there's a shotgun reload lock, right? There's 3 animations that you're playing here in a row, and on the same timeline you have 3 different animations that are playing. Now why would we want to do this? We can also name these animations. Here at the top where it says montage, you're going to see that there's a name where they're the default one, the default action that happens, then there's an action that says load and another one that says lock. You can actually play any of these sequences from the name, the friendly name here that's at the top, right? So instead of me loading multiple clips, I can use a montage, and I can do it this way, right? As opposed to multiple animation clips. So that's one thing it allows us to do. We can also blend from one animation to the other. That's also what it allows us to do, right? Which is pretty cool. And it talks about here how to create a montage in the documentation itself. Let's do it together. So what this is going to allow us to do is we want to make 2 montages. One that is, a montage that is for arms firing, and another one is for arms aiming. Okay, so let's do that. But in terms of doing that, we want to go into content, and notice what I say is inside of the blueprints folder, we're going to put in another folder called animations. Let's make a new folder, animations. And inside that folder, we're going to make a new folder called montages. So we're just keeping organized here. That's all we're doing. Okay, here's montages. Inside that folder, this is where I'm going to have all my montages in a bit. So what I want to do here is I want to right click and I want to go to animation, and I want to click animation montage. So this is the thing. So again, I'm right-clicking inside the empty montages folder, and I'm going to animation here in the menu, and then animation montage. So we want to call this montage, if you want to look at it, the AM for animation montage fire, right? So that's what it's going to be. So let's do that. So again, animation montage, and then we're going to choose the SK mannequin arms skeleton. This is the one we're going to choose, SK mannequin arms skeleton, and we're going to call this AM for animation montage underscore fire. Okay, that's the first one we're going to do. And what we want to do here is we want to choose in the default slot the arms fire animation. Let me show you what that looks like. So if I double click on the montage, and let's put this on the top here, there's a couple things you're going to note. Okay, on the left there are a lot of little options, right? The skeleton that you're going to use and so on. And on the right there's two parts, montage sections and asset browser. So if we click on asset browser, you're going to see all the animations, that are compatible with the skeleton. Okay, so if the animations are not compatible with the skeleton, even if there's other ones, you won't see them here. Okay, these are just a list of things that are compatible. So what we want arms fire. So this animation right here, arms fire. You can also search for it by just clicking on fire. And you can see there's a few of them, but the one we want is this one, arms fire, this one. And I want to drag it into the default slot like this. Okay, so I just dragged and dropped this one over here to the default group, default slot. And what we can do is we can test it, see what that looks like. So you can see that it has this little animation that kind of just does this little firing thing. And that's the first animation montage we're going to have. Even though it's a single animation sequence, we can still make a montage out of it. And again, there's advantage to using montages as opposed to using sequences directly. We want to avoid using sequences directly unless we absolutely need to. Montages give us more control. Okay? So that's that one. Let's do another one. So now that we have the animation fire, that's the first montage, we want to add in the arms aim fire. So there's firing, and when we're aiming, like aiming down the sight's firing. Okay? So let's do that. So again, let's do the same thing. Animation montage. And we're going to click the skeleton that we want, and then AM, and then it's called aim fire. AM, aim fire. And then when I double click on it, we can choose, by the way, I'm just going to change my editor preferences because it got wiped away so that I can use the main window here so it doesn't keep on popping up in a new window. I want to go to asset browser, and if I go to aim, right, you can see that there's a bunch of them. And one of them is aim fire. So this is the one I want to use, aim fire, arms aim fire. And you can see that that is what it says here, arms aim fire in the PowerPoint. So if I press play to play the animation and test it out, you can see now there's a bit of recoil. Okay, that's what you're going to see, recoil. Okay, awesome. So we've got this aims fire, and we also have the regular fire montage. There's two animations we're going to play with today. Okay, so save all. And let's put this up on DevOps. I say because we've done a couple of things, right? We've got Visual Studio open and everything else. How do you add this up to DevOps? Where do you do it from? What if we tried it? I'm just putting out there. What if we tried it from inside Visual Studio itself? So if I went to View and if I went to Terminal, and we're in here, and if I kind of go into the commands, it's like git add dot, right? There's my first command. So it actually allows me to do that, right? So here's where it is, git add dot, and then git commit -m, and we can say something like added, arms montages, right? And then we can push, and it should just work, okay? Should just work. So why am I doing it through Visual Studio? Well, here's a workflow thing for you. We're going to have Visual Studio open anyway, right? Because we're going to be working with C++, right? So why have a third window just for the terminal? Like a terminal window, and then we have Visual Studio, and then we have like Unreal Engine. Let's just have two things going. Okay, that's what I would do. The other thing is that you can do all the updates here and stuff like that, and it's pretty good. Plus, you can see the files that we've got open. So it's like two windows instead of three. But you could do it if you don't want to use Visual Studio. You can just do it with a terminal window as well. Okay, so now that we put this up on thing, let's check to see if our DevOps took. I always check for the first time, when I'm pushing, to see if everything is working out, because you guys are submitting things to me for marks. So these are always a good thing to check. And you can see that if in my history, I should have 2 commits now, initial commit and added arms montages. If you don't have these 2 things, or if you only have 1, or if you have none, or if there's none of this worked, then you're behind. Okay. Back to this. So now that I have the arms montages in play, right, we want to add an animation blueprint. So what is an animation blueprint? Again, please take a look at the documentation. I want you to think about an animation blueprint as the place where we're going to put all of the state machines for animation. So in Unity, your state machine was buried. Like you could get to your state machine because you have an animation, kind of a clip. And if you double click, you can right click and you can see your animation sequence in Unity. But the state machine was kind of all part of one thing. Here, what they've done is they've separated concerns so that the animation sequence, the animation montage, and your animation blueprint are all different things, right? But they all combine together. What the animation blueprint allows us to do is it allows us, to basically create, I'm just going to show you this for a second, state machines, all right? So it kind of looks like this, where we kind of set up a state machine, and the state machine allows us to create a set of states to go from one state, the initial state, to another state. Okay, that's what it does. So the documentation is really nice here. I think they've really done a good job. Way better than they used to have, by the way. Unreal Engine's documentation was always a mess, back in the day. Way worse than Unity's. Now, I would say it's really great, right? So, doesn't always cover everything, but it's here for you if you ever have a question. So let's do this thing. So what I want to do here is I want to skim up one level. So it says now that we have our animation montages, we can build another one. So I want to be in the same place. So back in here, I can go in. You right?
Yeah.
What happened?
Inside sleeves.
An inside sleeves. Okay, no problem. So. If I was to put it here, if I would go to, I want to make a blueprint, but it's going to be an animation blueprint. So I'm going to go to blueprint, right? If I go here, you can see that here, there's no animation blueprint. But what about animation? If I go here, animation, does have an animation blueprint. There's that animation blueprint right here. So animation blueprint. And again, it asks me what skeleton am I going to use, right? As an example, for now, there's other options too. But what skeleton am I going to use to do this blueprint? I'm going to use this one, SK mannequin arm skeleton, and click create. All right, and then I'm going to type in ABP for animation blueprint _ and then FPS character. So what this is doing is it's basically showing us that, why am I naming it this way? This animation blueprint belongs to the first player perspective character. That's what I'm basically saying, okay? You might have more than one animation blueprint, my friends, right? And you want to basically kind of tell in the way you put it inside your assets where they all go. Okay, so I want to save all right here. This little save all button right here. And then let's double click on the animation blueprint and see what it has for us. A couple things to note. Let's do a little bit of a tour here, okay? One, a preview of what you're going to see. Right now you can see that there's no animations, okay? You have access to the skeleton, right? You have access to the arms itself, the skeleton mesh, or that's what this is. So where this is the skeleton mesh. That's what that is. You also have two options to animation clips, and then at the top you have also things like the character itself, which is where we're at. On the top right, you can see that this parent class is the anim instance. That's the parent class of this animation. So if I wanted to make my own custom animation class in C++, I would basically make it from the anim instance superclass. So anim instance would be the superclass if I wanted to make my own animation blueprint thing in C++. Next, now that I have that, what I want to do is, and when I'm here, I'm in the anim graph, right? I want to create a new state machine. So this, by the way, on the top, let's do some navigation here. We have the event graph like normal. It has a regular event graph here, but it also has an anim graph. So the anim graph is where we define all of our state machines right in here. So I know it's a little bit confusing sometimes because there's a lot to remember, but don't worry, you have my documentation. So here what I want to do is I want to right click here, anywhere, and I want to type out state machine, like the whole word almost. And you can see that there is under state machine, there is state machine by itself. And here we're just going to call this locomotion. Okay, locomotion. So that's what we're doing. What we also want to do from this, remember back in aim fire, we had this default group slot. Remember this one? That's the aim fire animation montage, right? It uses something called a default slot. Now there's many slots you can define. Again, think about this as animation layers, if you will, okay? But for now, we're using the default slot. So what we want to do is here in my animation blueprint, I also want to use the default slot. And if we just kind of pull from here and type in, default, you can see that the default slot comes up, okay, which is what we want to do, okay? So, and then we can just drag from here into here, and if I kind of highlight them all and press the Q button, they all come in one line, okay? That's kind of organizing how you can do things, okay? So if I press compile and save, you can see now that there is an animation flow, but there's a bit of a warning that basically says, hey, there's nothing going on over here. There's no animation, so that's why the preview is blank. But you can see that this flow is almost like a flow of energy. But this is kind of what happens. The locomotion state machine, which is the upper level, goes through the default slot and then goes into our output pose. The output pose is the pose that you're going to see in the animation at the end of the day. Okay, that's the final pose that you're going to see. Okay. Next, I want to double click on my locomotion state machine. This one. I want to double click on it. It's going to take us down a level. Notice here now we have anim graph, and we're here inside the locomotion state machine. So this is down a level. This is almost like another level of things. We can right click to drag here on the left. And what we're going to do here is like kind of what it says here is we want to make a brand new state called aiming. So let's do that. So we're going to right click here and we're going to add new state, add state. We're going to call this aiming. There it is. And we're going to drag from the entry point a line. It looks like this arrow that's going to go right to aiming and then let go. Okay, so it's going to be kind of like this is our first state, the aiming state. Okay. And what we also want to do here is we want to create another state called not aiming. So there's two options, aiming or not aiming. So let's make another one. So dragging from here, and if I let go, we can actually create a new state, right? And we can call this not aiming. By the way, you can put spaces or not spaces. If you want to move this around, by the way, if I hover over on the edge, I'm going to get an arrow, right? But if I hover in the middle, you notice my cursor changes to these arrows. I can now move this around anywhere I want to make it, kind of more flexible. So I want to go from aiming to not aiming, right? So I'm aiming, which means I'm here, like I'm aiming down sights, as an example. If you take a look, right? I'm aiming down sights, and then I want to stop aiming down sights, right? So that means I have to go from I want to go from not aiming to aiming, right? So I'm going to go from here back to here. So there's two states, right? I enter the aiming state, right? I check something, and if these transitions, that's what these little buttons are right here. These are little transitions, little rules, if you will. It'll allow me to go from this state to this state. What will get me from this state to this state? What will do that? And for this, I'm going to add in two variables, right? Two variables. And on the left, I'm not sure if you guys have done this with Steve yet, but on the left, there's some options, right? I can add functions if I want. I can add variables if I want. And these variables are unique to this blueprint, okay? So on the left, under variables, I'm going to click on the first variable. I'm going to click onto it, and I'm going to call this is moving like this. That's the first variable. It's going to be a Boolean type. By the way, we're going to define other types later on, okay? And then I'm going to do the same thing. I'm going to click on under variables. I'm going to click this little button here, and it's going to just be is aiming. Those are the two variables I need, is moving and is aiming. Notice also there's a little closed eye here. It's okay, right? On the right, if I click on one of these two variables, doesn't matter what, on the right, you'll see some other options. One of them is the category. Remember we did this in C++, we defined a category? here we can define a category as well. And we can wipe this default name out and just make our own. For example, I'm going to call this one, I want to put this in under category combat. Right? Notice how on the left, variables are now organized differently. We have combat where is moving. I can actually collapse that, right? But is aiming is not part of that. You can't drag and drop. You have to click on is aiming, and you got to change now. Now that we've defined is combat, you can actually drag that and kind of assign that once we've done it one time. So now they're both under the combat category. I know these are little things, and you're like, who cares, Tom? Yes, you're right. It doesn't matter right now. But in the future, it'll become more complex. And that's why I'm showing you step by step what I would do. So here's something. If I'm going to transition from aiming to not aiming, guess what? Then is aiming should be false, correct? So let's double click on this little button up here. Take a look on this transition rule. Let's double click on that. If I double click on the transition rule, it takes us down a level into here, right? Where we have a result, okay? The result is the, I want you to think about this as the output node from this transition, okay? Notice that there's an input, can, enter, transition. It's a Boolean type. If I hover over, as an example, or if I look at this little red mark here, it's actually a Boolean transition. It's an expression that's evaluated to determine if the state can be taken, true or false, right? Which means I can kind of pull in my is aiming variable. And the way to do that, of course, is to drag and drop. If I drag and drop my is aiming, I get two options, right? I get is aiming and set is aiming. That's what I get. Get is aiming and set is aiming. So I could get is aiming, right? And I get this little new node. And now I want to know if it's not aiming. So what I can do is I can pull off of this node and I can type in capital N-O-T, right? And then Boolean. If I type in Boolean, you can see that not Boolean will give me this, not. And I can combine it with this. And I want to tell you how you read this right now. This is how you read this thing. You say this. You say, if is aiming not, if is not aiming, if it's not aiming, then transition to the not aiming state. Right? If it's not aiming, transition to the not aiming state. Right? That's what this does. Okay? So again, the way we got there, going back to the anim graph, just for people who somehow got kicked out. So if you double click on locomotion, you have these two states, as an example. We're inside of this state right here, this little rule right here. We went here, double click, right? You should have two lines, right? Two lines. There's a not aiming and not aiming, and then this one up here, right? So same thing with this one. If I'm going from not aiming to aiming, guess what I'm going to put in? Is aiming is true. Right? So let's do this rule. So double click on this rule. And then now here's a trick. If I take is aiming, and if I drag and drop it on top of this one, it'll automatically make that connection. Okay? So again, all I did was here, I'll delete that. If I take the is aiming variable and I just drag and drop it on top of this transition, it'll just connect it. And again, I can highlight both those and press Q, and it'll make it nicely like this. So this is where I'm going from, look, it even tells you the rule, not aiming to aiming. If I'm in a not aiming state, I'm not aiming. I'm not aiming down the sights. And I want to go to aiming, well, that's only going to happen if is aiming is true, right? I'm going to go look down the sights now. Then I'm not going to look anymore if it's not aiming anymore. So that's what this does. It transitions from one thing to the other. Okay? Are we good? Compile and save. Next, let's go back up a level. The way to do that again is I can go back to locomotion. I can use my kind of like these breadcrumbs up here. Come up here, and then you can see that this is where we have. Notice now that we have this thing right here where it says active. We have actually a flow now, right? Because we have rules. We say, well, and in the entry point, we come through, we go to aiming, and if it's not aiming, right, then I go here. And I'm going to stay there because there's nothing going to drag me back in here anymore. We don't have a state that takes us back right now. Okay, this is a good first step. So these are the two states. And one thing you can do is, these states haven't been defined. What is the aiming state? What is the not aiming state? Well, we can define sub state machines. Let's do that. So double click on the aiming state, right? And you can see that there's an output animation pose. And if you look here, what I'm doing with the aiming state, again, it's all in my PowerPoint, is I'm making a new aiming state machine. So again, I'm going to right click, I'm going to type in state machine. State space machine. I'll be okay. And then I'm going to call this aiming state machine. There we go, aiming state machine. In this aiming state machine, it's empty. If I hover over, I can see that there's nothing in the state machine. So I'm actually creating a sub-state machine when I'm aiming, right? A sub-state machine. That sub-state machine, right, is going to be depending on a couple things, right? Am I aiming and moving? So this is when I'm actually aiming, okay? So think about this. I'm in an aiming state, which means I'm aiming down the sights. So there's two options, right? If I'm aiming and moving, or if I'm aiming and staying stable, like straight. I'm just staying there and aiming, right? If I'm aiming and I'm not moving, I'm not going to play the aim move animation, which is kind of where my arms shake like this. I'm aiming and moving, right? But if I'm aiming and I'm stable, it'll stay like this the entire time. It'll kind of basically hover like this the entire way. But I'm here, like inside, I'm aiming down the sight. So those are the two options that I have here. Now there's other ways you could have defined this. I could have made a more complicated, lines like you've seen in Unity, where it points to, well, if you do this, then do this, and if you do this, then you transition here, and you do that. But this is a nicer, neater way of doing it, where now in this state, I'm aiming down the sight. So if double-click on the aiming state, I'm now into a new entry point. And just like it shows here, I want to choose two things. I'm aiming in idle, or I'm aiming when I'm walking. Okay, let's do those two states. Let's try this together, see if you can do that. So new state, okay, it's going to be called aim idle, right? And I want to make a new state from here, new state, where I'm aim and then walking, right? Like it says here, aim walking, aim idle. And then I'm going to go from walking to not a walking, right? So I'd be able to come back to this. So what would these transitions be, my friends? Let's think about from aim idle to aim walking. So let's double click on this one to create the rule. How do I transition from aim idle to aim walking? What's the condition? Can anyone think about it? Well, I have a couple variables here, and I can say if is moving is true, then I can transition, right? If I'm walking, then that's when I would transition to that animation. Okay? And likewise, when I'm not walking, double click here, I can pull in here. Now here's a trick, another trick, okay? Because this is not going to be a drag and drop anymore. I want to take the is moving, but I don't want to do this and select if it's a getter or setter. I want to select a getter out of the gate. The way to do that is to use the control key while I'm dragging for is moving. So control drag, it actually does this. If I do a alt drag, then I get this. I get the setter, right? So those are the options. Instead of me having to select, I can alt or control click and drag, and I get that directly. So I want to use control click to get this. And then from here, if I type Boolean, by the way, you can see that that's the quicker way of doing it. I have not, or XOR, or and. There's a bunch of Boolean commands. These are relational operators. Of course, I want the not. That's what I want. And then I want to connect them. And then I'm going to highlight the entire thing and press Q so that they're nice and orderly. And that is, if I'm not moving, then I'm aiming down the sights and I'm idle. Aiming idle. That's what I'm doing. That's the new transition. Are you with me? I know this is looking convoluted, but think about the original locomotion state machine as the hierarchical state machine, the higher level. And then you go down to two inner state machines, the aiming or the not aiming. Let's think about this now. Let's go back up one level. Now I'm back up to the aiming state. That's this state machine. Here, this is the aiming state. Let's go down in here again. I got these two states. I got the aim idle and the aim walking. Now is the time to actually allocate animations. Ready? Here's how we're going to do that. Double click on the aim idle state. I have an output animation pose. On the right, I can click on the asset browser tab, right? Here are all the compatible animations. What we want to do, if you think about what this says, it says aim idle. Okay, maybe we can find an aim idle. If I type in idle here, right, you can see that there's an arms aim idle. And I want to drag and drop this and connect it right here, like this, arms aim idle. By the way, you can preview this animation, what this looks like, if I double click on it. If I double click on this animation, it'll bring up the animation blueprint, right? The animation sequence. And then what I can do is I can actually press this to see what it looks like. Right? And again, you can't really see much, but I can do all the same control that I can do before. You can see that it's probably going to be just very small movements. when I'm animating idle, okay? One thing to also note is the animation, when I bring it to this place right here, when I drag and drop it in here, it is not looping by default. It only runs once. If I want this to loop, I have to go over here on the right, scroll down to where it says loop animation and click that checkbox. So please check that loop animation checkbox. If you don't, it'll only run that animation one time. We don't want that. We want this to loop forever, right? I want you to compile and save. So that is our first animation that we pulled in, the arms aim idle animation, because that's what we're doing, aim idle, right? Let's go up one level now, right? And I want to go into aim walking, okay, aim walking. So again, just like before, instead of idle, right, we want to aim walk. So if I do aim, you can see that there is an arms aim walk animation, arms aim walk. I can drag that in so we can have that arms aim walk. And then again, if I click on the arms aim walk, I definitely want it to be looping. So there's the looping animation. And then I compile and save. So now we have two states. We have inside of our aiming state, we have two substates. Okay, we have an aiming while I'm idle and an aiming while I'm walking. Good? We have two more to do like that. Firing while I'm idle, firing while I'm walking. That's also possible. Two more animations. Okay, let's try that out. So again, let's go back up to the locomotion, right? We can see now that there is aiming. We've already done that one. We need to do the not aiming. What happens when I'm not aiming down sights? Okay, double click on this one. We have a brand new kind of animation pose, the not aiming, right? That's the state. So again, if I go back up here, okay, just to show you this, we have this aiming state machine, right? And so if I go here, we need to put in a not aiming state machine. Let's do that. So we'll go kind of a new state machine, right? We're going to call this the not aiming state machine. By the way, if you spell it wrong, you can always change the name up here on the right. Okay, it's totally fine. Let's connect these two values up, make them so that they're queued up. So I like that. Compile and save. And inside the not aiming state machine, now we have two states, right? And just like we did before with the aiming state and the not aiming state, we have idle and walking, right? Just like same thing. So again, two states. So a new state called idle and another state called walking. Let's do them separately this time to show you that you can do that. Walking, okay? And then you can connect them all up manually yourself. So you can kind of drag a line from here to here, and then you can drag a line from here to here, the edges, and they can go back the other way, right? And now you have the same structure that we had earlier on, okay? So entry, idle, and then walking, not walking, right? So again, what we put in here is if I'm walking, I'm going to try just is moving in there, is moving, then we can queue that up, right? That's a option. And then how about if I'm not moving, right? So again, I can drag and drop the is moving in here and add in a Boolean, which is a not Boolean, and connect those up and highlight everything, press Q so that they're all lined up nicely. Let's try that again, Q. And then when they're in there, you can move them around like this, right? So compile and save. So that is your conditions done. Your conditions are over. If I go back up to here, the conditions are over. These are the conditions, but now we need to define the animations. So in the idle animation, we want to do what? This is, take a look what it says here. Not aiming, and I'm idle, but I'm firing. I know that this is happening. I'm not aiming, so let's take a look at that animation state where it says basically saying arms idle by themselves. So not aiming, not firing, kind of thing. Arms idle. So I take the idle animation, idle, arms idle, and then basically put it back here. We also want to make sure that this is looping. So click onto it and go down to where it says looping and click on loop animation. Select both those two and press Q. Right, there we go. Compile and save. And then we want to go out to this one, walking, and this is like arms walk, which is the next animation, arms walked. So again, if I type in walk, here you can see arms walk, drag and drop it on top of this pose, press Q, highlight and press Q, compile and save, and make sure that this arms walk is also looping. Guys, if you forget looping, it won't look right. Okay, compile and save. All right, so now my anim graph is done. That's all I need for this anim graph. Now we're going to make more complex anim graphs than this one. This is a simple one, believe it or not. It sounds complex in the beginning because we have so many layers, right? But reality is, it should make sense to you if you puzzle it out in your head. Questions so far? How are we doing with this one? Good. I know it sounds like a lot, but and it's just doing. You just need to do this more often. Once you do it a couple times, you're like, okay, I get it, you know, kind of thing, right? So, all right, so that's the next step. So now that we've got this part done, the next part is doing the event graph. All right, so let's get into the event graph now. And then I'll explain that. So the way to get to that easily is go to the event graph up here, but there's another way, right? For example, what if by accident I clicked all these and they're all off? That's possible. You could have done something weird like that. On the left, you can see that there's actually the graphs are right here. One of them is the anim graph. So if you actually double click on the anim graph, it'll bring that anim graph back up. Even if you lose it, it's right here. The other one is the event graph is right here. So if you double click on the event graph, it'll open up a new one. Or if you close this somehow, like I just did, right? You can just click on the tab. So you can move from event graph to anim graph. Okay, there's a couple things that are going on here. One of them is, notice that these things are grayed out. Whenever we see you know, an event graph like this, the reason why they're grayed out is because they're suggesting that this is probably where we need to start, but these are not implemented. That's what they mean, right? So one of them is the event blueprint update animation. So that means like every update, I want you to think of it this way. The animation itself is going to have its own update loop, in a separate thread. You know, think about this as a coroutine from a Unity perspective, but its own thread is going to be running this animation, right? That's what it's going to do. And then we're going to try, it says try and get the pawn owner. Remember the pawn, when we say pawn, don't be confused. Character is a pawn. It inherits from pawn, and because our character, which is FPS character, which we wrote in C++, also inherits from character, so does ours. Ours is a pawn, right? So that's the first thing to know. And then what you can see is we're going to get something. We're going to get the velocity from our pawn. So we're going to try and do that. So we're going to say drag from here, and we're going to say get velocity. So question for you guys is, how can we get velocity? Why is even velocity a thing in a pawn? Can you puzzle that one out? Yes? They move around. Pawns and characters move around, so that chances are there's velocity. Well, we don't want just any velocity. We want to get, if I pull this out again, I want to type in xy. I want to get the vector length xy. In other words, I want the magnitude or the speed. That's what this is. It says, hey, get the velocity, and xy is on the ground. Remember, in what we're doing here in Unreal Engine is z is up, right? So we don't care about the z velocity. We only care about the x and y velocity, how they're moving on the ground, right? So that's going to give us our vector across that xy plane, as opposed to the xz plane or some other plane, all right? The xy plane itself. So now that we have this velocity, this is in fact the speed. That is the speed that we want. And notice if it's moving here, we can test for that. We can say if our velocity, we can use a greater than symbol here, like this, right? So I pull off and I just do greater than. If my velocity is greater than 0, guess what? That means we're moving. It's very simple like that. Now, some people use a threshold. They don't like 0 because it's a real number, right? So they might use like something like 0.3. They want to wait for the velocity to increase a little bit. But here I'm going to leave it at 0 for today. Okay? If this is true, it gives us a Boolean output. This is the output. If this is true, this is going to give us true or false, right? That's what it's going to do. You can also put another condition in here. If you want to, instead of having it 0, you want to put another option in here to say like there might be a minimum velocity. That's the minimum threshold, if you will. You might want to define that later on. For now, we're going to keep it like this. So if this is true, what do we want to say? We want to set is moving to true, right? So we're going to use alt drag. Take a look, alt drag right onto this point right here. And if I let go, is moving now is set to true. But we have this dangling execution pin, right? Remember, it's never going to get here unless these two execution pins are connected, right? So we need to connect these two together, like so. And now we have, a event graph that looks like this. Okay, compile and save. Are you with me? So really, instead of me telling it I'm moving, it's going to look at my character, the character that is attached to this thing. The reason why it's trying to get the pawn owner is, what if my animation doesn't have an owner? It's not connected to anything, right? Then it's not going to do this. I don't want to even run the update loop. Who cares about the update loop if this isn't connected to anything? It's going to waste my, cycles every frame. I don't want to do that. So it's only going to do this animation loop if I'm connected to something. That's what this is. Try get pawn owner is like, hey, am I connected to something or not? Okay. My friends, this is a great place to put this up on DevOps because we've got some good stuff going on here. Back to Visual Studio where I'm going to use this. I'm going to say git add dot, git commit -m, and we're going to say added ABP FPS character. That's complete, right? And then notice it added a blueprint, and just exactly what we did there. And then I'm going to git push. Git add, git commit, git push. Git add, git commit, git push. I want you guys to get in that workflow. That is the protocol that we're going to be using throughout the semester. And I want you guys to do that because when it comes to your midterm test, it'd be a very bad thing if you lost marks, stupid marks for GitHub or Git. Where you could have pushed a couple times, you're like, oh damn, I forgot to push. Now I'm gonna lose marks, right? I want you guys to demonstrate that you guys are working with your version control system, and just for the reason what we had earlier. Remember that problem that I had where I couldn't even run my app? Well, thank God for version control, because I didn't have to do all that stuff again and generate the ICE3 again. Imagine that if I had to do all that. It's like a waste of time, right? But I was able to recover in a fairly reasonable manner. All right, so now that we've got this thing, we need to attach it. The blueprint on its own doesn't do anything. We need to attach this whole thing, to our character. How do we do this? So back to our test map. And what I want to do is I want to go swim up to blueprints where I have my character. Here's my character blueprint. And I want to double click on them so that they can come up. There's my character blueprint now. I'm just going to drag this so that my character blueprint looks like this. Test map, character blueprint, and then my animation blueprint. But it's up to you how you want to do this, okay? My character blueprint last time, if I hover over the mesh, right, as an example, the actual character mesh, you can see that I used a animation asset on the right-hand side here to preview, which is my arms idle. I don't want to do this anymore. I want to use an animation blueprint because we have one now, right? So that's the option. And notice this is anim class. Anim class is going to be the ABP FPS character. So the only ones that come up here are the ones that are satisfy the anim instance class, thing. So you can see that is the way it is. Take a look. So that's ABP FPS character, right? And that is the anim class. Compile and save that. You're not going to see all the changes yet, but what you're going to see when we play is if I'm hovering, I'm idle, still working, right? But if I move, you're going to see that, kind of like the arms are arms walk now, right? Arms walk. Yeah, don't do that. That's a thing. Okay, so there's arms walk. No matter where I'm moving, arms walk is happening. Okay? And then it goes back to arms idle. And you can see the transition is not so bad. Okay? Are you with me? So how did I do this again? One more time. I finished my ABP blueprint, right? My ABP FPS character. This is all done. I've done the event graph. Everything is working. And notice here, I also have one thing to check in my ABP FPS character is I have a preview animation here. Take a look at this. I must have a preview animation at this point. If I don't, then something's not working. You haven't connected things up properly. So that's one thing, okay? And the next part is in my BP underscore FPS character, under my mesh, I clicked mesh. I must click mesh. On the right-hand side, this is where I choose the animation mode. I had animation asset, but instead I moved to animation blueprint and I selected my blueprint. That's what I had to do, all right? Those are the options. Once I've done that, now my blueprint is connected. Next, I need input. Without input, I can't choose that I'm aiming or firing, okay? So I need to add 2 more input objects in here. So if I go down, that is the new thing I'm going to do. I'm going to go in, I'm going to create two new ones. They're of type Boolean. One is IA aim, and the other one is IA fire. Okay, I have a problem though, and I want you to tell me what that problem is. So let's do that first. So back to here, I'm going to go into input, here it is, into actions. I'll make two new actions. I'll make, again, it's under input. I'm going to go to input action. I'm going to call this IA aim, and another one, which is going to be called IA fire. So IA aim, IA fire, and I'm going to save all. There we go. So I've got two more actions, and inside of I want to go up one level to input folder, and I want to go to the IMC FPS thing. So that's input mapping context FPS, right? And in my mappings, you can see right now I have three mappings: jump, look, and move. And I'm going to add two more mappings, right? And just to keep it the same as the PowerPoint, so we're not confused, I want to do aim and fire, right? So that's what I'm going to do. So back to this, I'm going to add two mappings. One of them is going to be mapping to aim, and the other mapping is going to be mapping to fire, okay? For aiming, let's open this up. How do I want to aim? My right mouse button. When I click my right mouse button, that's when I want to aim down sights. That's typical. So I can click on this little keyboard icon, and if I press the right mouse button, it's going to assign the right mouse button to it, okay? Or you can select it. You can go to mouse if you want to do that, and then you can go right mouse button if that's easier for you, okay? Same thing with here. I can click this little keyboard, and I can click it again with my left mouse, and now I have my left mouse button. All right, so those are the buttons that I'm going to be using. So this is a really neat thing. One thing I really love about Unreal Engine is you can really assign keys, you know, to this stuff. And what about if I had touch controls? If I was going to make a mobile game, right? You can actually assign touch, controls as well to this, as opposed to just whatever. You can assign multiple inputs to do the same thing. Like for example, one thing we had here earlier with moving is I had these WASD keys. What if I had a person who is left-handed, right? Who controlled their mouse with the left hand, and on the right hand they want to use the arrow keys. That's a problem, for if we don't have anything. We want to be able to add those in, so we can add those arrow keys in there as well, if that's what you want. Later on, what we might be able to do, maybe not this semester, but next semester, maybe we'll create a menu that allows me to remap our keys to other keys, where I can say, I want to choose this one, and I can do the remapping in an option menu, which is normal, right? We should be allowed to do that. All right, or allow our users to do that. All right, so let's save this. So now that we have this, this is great. We've added some mappings. We've added some actions and mappings. Let's put this up on GitHub or DevOps. So git commit -m, we'll say added IA aim and IA fire. Git push. Notice I added two assets and I added a commit. Why? Anything I add, modify, or remove, we should be doing a thing. If I'm fixing a problem, a bug, I should do a commit. Okay? I fixed a bug. We want our main branch to be error-free. Are you guys good? Okay. So now that we're going back to this, now that we have our actions, we have a problem. And remember what we did here, right? We used C++. This is what we had here, and even if I had those actions, if I was to map them down here, would they work? Look, we disconnected our input mapping context up here, right? Notice? Which means that without this in here in blueprints, if I did a blueprint down here, if I'm going to prototype it in blueprints, this would never work. My friends, we have a problem, right? If I was to do this, let's do this together. So if I was to kind of right click and go, IA aim, let's do that one first, right? You can see that this comes up, and I can do whatever things I'm going to do in here, right? In the future. Don't do anything else, just this, IA aim, right? Remember, this blueprint prototype will not trigger at all, ever, unless I have an input mapping context together with it. However, we're doing things with C++, right? So our movement is in C++. We have a mapping context. If I go back to C++, let's take a look here. Here's our FPS character, right? And then we have a mapping context we've defined, right? This is it right here. Here's our FPS context. That's what that is, right? And then what we do is we activate it in the CPP. So back in the CPP, you can see here that if I scroll down to the begin play, right? This is where my input mapping context is happening, which is an analog. Same thing happens. That's what analog means. There's an analog to this, which is here, right? You can see here, there's my begin play, right? And we do the mapping right here, just like we do it here in C++. Same thing, right? So we have a decision to make. Do we continue with blueprints, or do we do C++? And this is, remember, this whole decision point. This is what this course is about. When do I use C++, and when do I use blueprints? I'm going to tell you this, that when I code in Unreal Engine, me personally, I always prototype it in blueprints first, because it's easier. Okay? Once I know it works in blueprints, then I have the blueprint for what it can look like in C++, right? If it doesn't work in blueprints, it isn't going to work in C++, and vice versa, all right? Chances are. So let's not do the C++ right now. I'm going to leave that as a challenge to you guys, all right? For now, I want to go back to this and reconnect the event begin play cast to character. Now, this is not going to invalidate the work we did last week, because notice that these are still not connected. I don't need to connect these. I just need this to be connected so that my input mapping context is connected. Once I have that, then I can do whatever I need to do, okay? So that's the first step. The second step is, as I'm going down to aim, I got to think about all the little things I need to do when I'm aiming. So back to my PowerPoint, right? I connected this up. That's what I said. And then the next thing is, I'm going to make my aim node look like this. So let's do that. So one is, I'm going to pull my mesh in. Okay, let's go back to that. So back to this. To get my mesh, here's my mesh up here. I can just drag and drop that from here into my event graph, like so. Okay, that's my mesh. Why do I need my mesh? Because I'm accessing its animation blueprint, right? That's what I'm trying to do. So back to the PowerPoint, what you're going to see is it says get anim instance. Get anim instance is like saying, and I want you to remember this in your mind for future reference, guys. If I say get anim instance, I'm saying I want the animation blueprint. That's what I want, okay? Because the animation blueprint is a child class of the anim instance superclass, then I want to get anim instance. Why? Why didn't they just say animation blueprint? Because I could have my own custom anim instance in C++. It doesn't know. We want to make the blueprints flexible enough to grab an animation blueprint from C++ or from blueprints, right? And so we have to keep flexible. And that's why that says get anim instance. That's the next thing you're going to do. So from here, drag get anim instance is basically saying, hey, I want to get this one. But an anim instance could be anything. And we need to cast this so that it looks like our anim instance, which is ABP blueprint, right? So again, notice it says cast to ABP FPS character. We're going to do that cast to ABP. There we are. And now we're going to figure out what's happening. Well, there's a trigger. When I'm aiming, that's what happens, right? That's when I'm aiming. I can trigger it, right? And there's another instance when I'm not aiming anymore. It's completed, right? So I want both of those two things. This is where I have two inputs that go to the same thing. Okay, and I can use a little reroute node here, double click, to make it a little bit nicer. There's other ways to do this, okay? I'm being honest, right? Here's something. There's two states. There's the triggered state and the completed state. So I'm right-clicking and I've let it go. Okay, that's what it means. So either one, I'm going to go to this blueprint. From there, from the blueprint, what do I want to do? I want to get if I'm aiming or not. So if I do something like get is aiming, take a look at that. I can say get is aiming. There it is. Get is aiming, right? And I get a chance to drag that off the blueprint. I know that I'm aiming or not. And if I'm aiming, right, then that is a really cool thing. So that is, I can get what I'm aiming, but what I want to do instead of getting that I'm aiming, I want to set I'm aiming. So again, I can say set is aiming. And set is aiming, I'm going to connect up to my little execution pin here. We can make this a little tighter. I can move all these to the left a little bit, right? So you can see it all on one screen. On the left, you see an action value. The action value is a Boolean. It's either true or false. That's what this is. So then I can pull this into is aiming or not. I can set up if I'm pressing the button, then I'm aiming. And if I'm not pressing the button, I'm not aiming. like so. Are you with me? I know this can be confusing, but it's like this. It's like almost like if I was going to do this in C++, I would say something like this. Get mesh. From the mesh, get anim instance, right? Cast to BP underscore FPS character, right? And then once I've done that cast, that's kind of like the first line. And then the next line would be, okay, now that I've got the, the anim instance, let's just call it a name. In C++, I would name it something like ABP underscore FPS character, right? And then I would say arrow, which means from that, set is aiming, and then once I'm setting is aiming, I'm setting it to whatever my action value is from that little function. Maybe I'll have an aim function that does something similar to the move function. And going back to this, remember I have two functions here. I have a move function and I have a look function. So I have look functions that have an input value. That value is either, in our case, for aiming and for firing, is a Boolean type, not a vector type, okay? Just letting you know. So that's how it works. So I could do this in C++ as well. Okay, back to this. So now that I've got aiming, let's test it. So back to this, I'm going to say compile and save and test. And now, if I press the right mouse button, you can see that we're aiming. We're not aiming anywhere special. We're aiming in a weird, our gun is like pointing down like at the ground somewhere. I don't know what the heck's going on here, right? But at least it works, right? Yeah, it works. It does work. The aiming does work. We're aiming just in the wrong spot. So it's terrible. All right, yeah, it's like way out there. So next, now that I've added aim and connected it, we should put this up on DevOps. So back to this, it's git commit -m, and we'll say added IA aim event to BP underscore FPS character. So notice that I updated one thing. All I'm keeping track of step by step is what I'm doing. So that way, worst case scenario, if something breaks or my dog eats my computer or whatever, right, that I can always go back and, whatever. Yeah, it can happen. For me, my little dog, which is a Doberman, he's pretty crazy, and he'll just jump on my. If I'm busy with my computer, he'll just put his paw on my computer. One of those, right? And I'm like, no, don't do that, and he doesn't care. He doesn't know what I'm talking about. He thinks it's a game, right? So, next step. Now this is where it's new for you. Okay. Right now, our aiming action isn't that great, right? And what we can do is we can configure aiming so that it aims a little better. So the way to do this is, if I go back to the aiming itself, back to this. So we have aiming, right? And what we want to do is we want to go into that specific place. If I go to the mesh arms, I want to open the editor, right? And we have a preview of what this is going to look like, right? And I want to look at the arms aim idle animation. That's what I want to do. I want to select that as a sequence. Let's do that. So back to this. I'm going to go to mesh, and I want to double click. Oh, sorry, the gun mesh. No, I think I was right the first time. The mesh, and then double click on the skeletal mesh asset. This one. And notice that it looks like this, and that's really ugly. So again, I can look at, just like it shows here, right? I can look at a specific animation. So at the bottom, you can see there's a skeleton. There's details on the details, right? Doesn't show us anything, but in the asset, there's a preview on the preview tab. On the preview tab, you can say instead of preview controller being default, we can choose a specific pose, right? A reference pose, or use a specific animation. And in here, what we want to choose is arms idle, arms aim idle. So we can say arms aim. If I just kind of filter aim, arms aim idle. That's the one I want to use, and you can see that that is the animation. Now, it is moving, my friends. See on the bottom here where it's moving? Please stop it from moving by pressing the pause button, okay? And then what you want to do is you want to zoom in. Again, control-wise, I like to really zoom this down to something like even 0.33. 0.033. So I can kind of zoom around here, and so I can look at the arms very, very closely. I can do one of these, look. There's lots of control here. So you can see if it's like where the position of the hands are and all that kind of stuff, okay? That's a great thing. So that's the gun. For now, what I want to do is I want to make this thing aim a little bit up, right? Because right now it's aiming down. This is incorrect for the final build. The final build, we have to look at a reticle. Right now, this is not looking anywhere. It's just, I don't want it to look down, I want it to look up. So here's the fix for now, okay? I want to click on the grip point over here. I've kind of navigated here in the skeleton. I've got the grip point, and then under details, now you're going to see these numbers, right? Which is the relative location and rotation and all this kind of stuff. Please use my numbers, these numbers right here. So I recommend them. So just take these numbers here, X, go back over here, double click, actually just select all, that's probably the way to go, and paste. And I'm just going to grab all this. And you're going to be like, why, Tom? But why? You'll see. It'll save us some time. Instead of us putting around right now, I want you to putt around later. And same thing with the rotation. I'm also changing the rotation a slight bit. Okay, just so that the rotation is perfect, and then we'll go and I'll show you how to do this later for yourself this day. Okay, so there we go. And now I have rotation, location. The scale remains at 1, and now my gun is moved. And these values here, this is important. These values here, when I'm clicking on the grip point, that's where I'm moving, the grip point, not the middle finger or anything like that. The grip point, I'm getting this. This is what you should see. These are the actions. Okay? I'm moving that around. So let's say save. Okay. So what have I done? I've moved my gun around. It's not quite perfect. You can see it's not perfect, guys. Look. 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 It's not perfect. Okay? But it's good enough for now. We're going to fix this problem later. Like, it's clearly not like right. It's not right. Okay? But what I wanted to do is at least test to see if the arms look proper. So when I do this, and if I do this, it looks a little better. See that? Take a look at that, looking down the sights thing. Look at that. Right? You can see, actually, I see my sights in there now, right? Which is a lot better. So it's more of a simulation than what it was before. It's not accurate, and it's still, notice my arms are still going into my face, right? Which is not really great, okay? But for now, we're okay. All right, so that's what this is. I want to configure the fire action now, and after this we'll take a short break again, because there's a lot, right? But the fire action is going to need a few things. I need some kind of burst point, a place where I want to have a muzzle flash. I want to actually add some special effects now. And I want to do some other stuff, but there is something I need you guys to download from Blackboard. Let's do this together. So first, before we do any of this, let's go up on Blackboard. So I'm going to go to Blackboard as well. So I'll do it with you. Here's Blackboard. It's going to ask me to log in, And then when I've logged in properly and I go to our course right here, you're going to scroll down until you get to weekly content. Under week 3, you're going to see that there is another download, which is this weapon.zip. See weapon.zip? I want you to download the original file, right, weapon.zip. And I want you to put this weapon.zip inside of, for now, your project, okay? And we're going to do this properly. Save it there, and then we're going to delete it in a second. So I'm here. Here's my weapon.zip, right? And I talked about this last week, how we want to unzip it with 7-zip, right? So I want to right-click, and I want to go Show More Options, and I want to use 7-zip and extract to weapon. Extract to weapon. So there's weapon. Now that I have weapon, I can get rid of weapons.zip. I don't need that anymore. I've extracted to weapon. Now, how do I add this in to Unreal Engine? Unreal Engine has the content system, right? So here's our content. This is different than in Unity. In Unity, you would, I could recreate this stuff manually. Okay, I don't want to recreate nothing manually. I want to give you all my assets, and then I want Unreal Engine to import them instantly. All right, so how do I do that? Under Content, everything that you move or migrate, that's what it's called. If I want to migrate content into here, this is where I would put it. Now, weapon needs to be put in a special spot. When I get it from my project, my weapon content was inside of my assets folder. And because it came from my assets folder, it needs to go back into my assets folder. If you just put it in the content folder, it will fail. All right, so don't do it. So what I mean by that is, go back out to here. I want you to hit my weapon, cut it, so Control X, where I'm moving it. You can also right click and cut, and then, or choose this cut button, and then go into content, assets, and then from here, Control V, which is going to move my weapon inside of assets. Now, Unreal Engine is still running, and if I go here, now I should see weapon in here, and if you see that there's no files like this, right? What you may need to do is close Unreal Engine and do it again. So let's do that. So let's go back out to weapon. Notice that it's inside of content assets, and I want to get rid of it, so delete it, right? Notice it deletes from Unreal Engine as well. It's gone, right? What I want to do is I want to file, save all, and I want to close Unreal Engine down, the editor, right? And then I want you to get that weapon back in here, all right? That's what I want you to do. So again, what you have to do is I deleted it, right? So you may have to get a fresh copy from Blackboard, or if you kept it, that's even smarter than me, right? I'm just going to grab this and put it inside of where it's supposed to be. So you can actually even put it in the right plot. You put it in content, assets, and I can just put it in there if I want. And then what I can do is, if I open that up, here's weapon.zip. I can just do the same thing. I can go to show more options, 7-zip, extract here to weapon. There it is. And then what I can do is I can delete my zip archive, and now I can relaunch Unreal Engine by double clicking on here, relaunch, and it should import everything again properly. Should. Okay? If it doesn't, we're going to take a break and I'll fix it. Okay, let me take a look here. So if I go to assets, first of all, let's open this up so that remember. But let's go to assets, weapon, and then now under FX, you can see all the stuff that we need for our weapon. So what I've given you here is a bunch of stuff. I've given you muzzle flashes, I've given you some explosions, some particle effects, and all this kind of stuff that we're going to use. So if you don't have this, remember what I did? Close down Unreal Editor, open it up again. With weapon in the right position, everything is good. Okay. All right. Now let's put this up on DevOps, because we have more stuff that we just added, right? So git add dot, git commit -m, and we'll say something like added weapon effects. There's a lot there, so it's going to take a moment to push that. So I've given you like 100 megabytes of stuff. Doesn't look like much, but actually it's a lot. Wonderful. Okay, great. Back to this. So now that I've given you your weapon assets, right, and stuff like that, there's some more complications here, right? So let's go back to this. We've got all these. I want to do these things. I want to do a muzzle flash at the point in front of the weapon. Let's call this the burst point. I want to play a weapon fire sound, right, which we're going to do. So when we, we go, we're going to hear the fire sound. I want to perform a line trace. This is kind of like a ray tracing. Think about this as I'm using a line of sight. I'm going to draw an imaginary line from the tip of my weapon all the way forward, right? When that line is drawn, I'm only drawing that line when I click the fire button. So what it's going to say is, can I hit something, right? And it really depends on what the numbers I use, what my range is, okay? So the bigger the number I'm going to multiply, then the longer my range is going to be. Anything outside that range is going to be missed because it's outside of the range. It'll only draw a line as far as I tell it to, right? It won't go forever. And this is good because you don't want to be able to fire at something necessarily with a pistol in a game, unlimited range, right? It's going to fall off in real life, right? That's why we use rifles. Rifles have much longer ranges and they're more accurate, right? So, so if you try to fire something at someone that's far away, you know, and if you have a range number in your game, let's say, for example, you decide that the range is 100. I don't know what that means. You can assign that number, maybe it's 100 meters or 100 whatever, into a range that we're going to be able to shoot. Rifles have a very long range, usually like in kilometers, so usually we're going to multiply it by a bigger number. Okay? So that is what we're going to do with line trace. Then we're going to have impact particles. So when we hit the ground, it's going to make these little like rock effects come up, and they're going to disappear by themselves. Okay, that's what we want to do. For that, then we want to start by doing a couple things. First, we want to add a burst point, right? And a burst point we're going to add by going into our BP underscore FPS character on the gun mesh, and we're going to add a child of the gun mesh, which is going to be a scene component, this one, where it says scene, okay? Don't be fooled by what this says. This is going to be the burst point. Scene, in your mind, if you see a scene component, okay, I'm going to give you the analog in Unity. It is an empty game object. Empty game objects in Unity, what they give you is location, rotation, and scale. They just give you a transform. That's what they give you. So too is this. This scene is just a point in space that has no rendering ability whatsoever. There's nothing you're going to draw here. In anything, it's just an empty container. Put it that way, all right? So that's what it is. So that's the burst point. If we go back to our viewpoint, though, a viewport, our burst point is like way in there, right? So I've given you I want to change the location of the burst point so that it's in front of the gun. You could try and do this manually yourself, okay? But I've given you some values that I want you to use. So which is X is this for the burst point. So that's where the X location is going to be. Then there's the Y location. This is relative to your gun, by the way, because it's a child of the gun. It's using you know, kind of local space as opposed to global. And now what you can see is if I kind of look, if I zoom in, so I'm going to do the same thing like I normally do. I'm going to just turn this right down to this. And I can zoom in to the burst point here, right? And you can see that if I use my controls, my fly-through controls properly, that you can see where the burst point appears right here, right in front of the gun. See that? And that's where yours should be too, if you use the same values that I've given you. So this is where we're going to see the muzzle flash. The muzzle flash is going to appear in front of the rifle, right? That's where it's going to happen. Okay, compile and save. There we go. That's awesome. That's great. All right, so we've added a burst point, and the next step after adding this burst point is we need to, I talked about this already, we did this already. I want to create, you know, 3 different variables: muzzle flash, weapon fire sound, and impact particles. Again, when we're creating variables down here, let's do them with care. So the first thing is the muzzle flash. Let's do that first. So add new variable, we'll call it muzzle flash. Now this variable is a instance variable, which means it's available to anything inside of the blueprint. Okay? Here what we want to choose is the type. So this is important. The type is not a Boolean, it is a particle system. So we'll type in particle system. You can see that there is a few of them. We want this one, the bottom one, particle system. And we want it to be an object reference. Okay, object reference. I want you guys to think of an object reference as a pointer. If I click onto it, it's a pointer, it's blue. And on the right, you can see that that is what it is. The variable type here, you can also assign it here, is a particle system. Okay, so it's just like, you can move these things around so you can see that all. Particle system, right? You can also change the variable type up here. We also want to put it in its own category. Let's put it inside of combat. So again, we can kind of take this category and put it in combat category because we're going to have a lot of variables. We have components right here, but we also have variables, muzzle flash. Okay. I then want to put in a weapon fire sound, which is of type sound base. Okay, so again, a new variable. We're going to call this, like it says here, weapon fire sound. So we can, if you didn't do this, you can just click on this again, weapon fire sound, and we're going to, the type is going to be sound base. So if I kind of hover or search for sound base, like this, sound base, if you really want to go there, there's bases and there's also sound base. you can see that there is a sound base object, and then we want to make it an object reference again. Sound base, weapon fire sound, okay? And then we're going to add in another variable, and it's going to be called impact particles, but it's going to be another particle system. Impact particles. And again, we're going to make this a particle system type. Here it is, particle system, right here, object reference. All right, so there's the few, and we're going to make weapon fire sound also in the same category. We're going to put it in combat. We also want to say impact particles is also in the same category. We're going to put that in combat as well. So now they're all in the combat category. This way you can always collapse that category if you don't want to see those variables. It can take up a lot of space. Eventually there might be a lot of variables inside your blueprint, and you want to organize stuff. All right, let's compile and save that now. Once we've compiled and saved, if I go to the combat category, so if I click up on top of the character itself, this BP underscore character, and if I go here to the details and I just hover for combat, now you're going to see these variables, right? By the way, this is another reason why we want to do this. So we want to kind of be able to, be able to search for it here. Muzzle flash, if you notice what it is, I've given you what it is. It's called P underscore assault rifle muzzle flash. That is the particle system. So this right here, P underscore assault rifle muzzle flash. The only ones, remember, the only ones that are going to come up here are the ones that are compatible, right? The weapon fire sound, that is going to be called the assault rifle shot, right? So again, if you kind of look here, assault rifle shot, you can also filter for it, it'll come up. And then the impact particles are going to be the things that I'm going to be using. It's called impact metal large. So if I look there and if I type in large, then I can see impact metal large. So why is that? There's different impact particles. You can, with your line that you're going to cast, detect what you're hitting. If I'm hitting flesh, if I'm hitting wood, if I'm hitting metal, and you can change the particle type and the sound type depending on what you're hitting, right? Same thing when you're walking. When you're walking on concrete, when you're walking on sand, when you're walking on whatever, you can change the sound type so it sounds proper, okay? But for now, all we care about is we're going to make it very basic, so we're going to just do the same thing no matter what we hit, okay? Compile and save. So now that we've got these, we've got our references for the things that we want to do, right? But we haven't done anything yet. Next. What we want to do is we make a new function. Have you guys done functions with Steve yet? Awesome. So we want to call it play muzzle flash. So that's the name of the function. We can double click here and do that. So I can come to functions, click that, and kind of paste that in, right? Play muzzle flash. I want you to think about what this is, okay? One more thing. So I'm going to just review this with you as if you've never done it with Steve. A couple things to note, right? One thing. There is no input, and right now, play muzzle flash has no output, okay? If it did, then you would have an input node here, and if it was an output, there would be a return node over here. We don't have a return node, which means it doesn't take an input, doesn't do an output. All it does is do something for us, and that's it. So what we want to do is exactly what this says. I want to get the burst point. The burst point is right here. Here's my burst point, which is just an empty object. And then from the burst point, we want to get our world location. So we want to, again, drag off of it for get world location. There it is for our burst point. And then from the world location, let's also get the muzzle flash. Let's get that too. So muzzle flash, again, is here. So we'll get the muzzle flash. Muzzle flash is a particle effect. That's what it is. And what we can do is if I type in the word spawn, from the muzzle flash, you can see spawn emitter at location is what it will happen, right? So we can actually kind of spawn this system. Spawn emitter at location. There we go. And then we can connect these like this. So the location would be the burst point. The burst point's relative location in the world. Okay? There we go. And we can make this, if you really want to, you can kind of hit this one, and then press Q, and it'll line up exactly. So this is the play muzzle flash effect, right? So it'll get the burst point, it'll take that muzzle flash particle effect, and it'll spawn the emitter at that location. Remember, an emitter you can have multiple emitters for an effect. Right now, we're only using one emitter, but I can have, if I want to make smoke and fire I can have fire that does the fire, emit fire particles, and then I can do another emitter in the same location when I do smoke particles, right? So you have that combined effect. All right, so that's what that does. And now let's do the second one, which is play weapon sound. I don't really need this, but this is pretty cool. I was just using a lot of functions. Last semester, last time we did this, they called me function queen, right? Because I'm making all these functions all the time. So go back here, make a new function. We'll call this play weapon sound, right? Play weapon sound is going to have two things, the fire sound, and we're going to play a 2D sound. I'll talk about that in a second. So I'll get the fire sound. And then from there, we're going to play 2D. If I just type in 2D, we can say play 2D sound. So why 2D sound? There's two types of sounds that you can make in Unreal Engine, really. You can play sound at a specific location, and then you have attenuation. So if you're far, far away, you won't be able to hear that sound. For example, if there's fire crackling somewhere else, you don't want to hear it all the time, like when you're far away from the fire. Imagine you're hearing fire sound when you're playing the game, you're like, where's that fire coming from, right? That's a 2D sound. So I could emit the weapon fire sound at the location that it spawned, which is the tip of my weapon. That's more accurate, but it's also more expensive. Playing 2D sounds is a less expensive operation because you don't have attenuation. It's right where your player is. So if you're going to fire a lot of shots, remember, sound and generating sound is expensive. It's an expensive operation per frame, right? So we want to keep that, that cost low. So we play the sound as, kind of 2D, which is like low quality, which is good enough, is what this is. Okay. So that's our play weapon sound. Next, this is a bigger one, and I'm going to talk about how to do this. This is perform line trace. This has an output. Take a look at this. It has an impact point as an output, but we're going to build it, kind of thing. It also has a local variable named start location. So I want you to notice that there is a local variable here, and we're going to talk about how to make local variables if you haven't done it already, right? So first, let's make the function, perform line trace. So here I'm making a new function, and we'll make this perform line trace. And to add a local variable here, right, there's variables, and then there's local variables way down here. All right, so if I click local variable, right, and if I use start location, it's way down here at the bottom left. And this is why I can collapse some of these things. So I can see local variables here. It's not a particle system. It's actually a vector, right? By the way, C++, it's an F vector if it was in C++, okay? F vector, because it's a struct. It's not a class. And it's yellow like this. All right, so that's the start location. And then what I want to do is I want to get the player camera manager. I'm going to zoom in here for this thing so you guys can see it. So get the player camera manager is the next thing I want to do. Okay, so I want to do that. So get player camera manager. There it is. So the camera manager, what it does, it looks where the player is looking. There's two things the camera has. It's what the player's camera itself is actually looking at right now. Notice that we have a camera. Here's the camera itself, right? Normally what we would do is check to see if whatever the player is looking at, we want two things. We want to, where the camera is looking, we want to get the actor location, the camera's location. Okay, that's the start location. So we'll get actor location. By the way, this is not the location of the character. This is the location of the camera because the camera is an actor. Why? Remember back to the hierarchy again. Actor, pawn, character. Actor is any game object in the game, anything. So if this is Unity, it would be like get game object. That's what this is. Get game object location. That's what this really means. So what's the object location of the camera? The camera itself and the character's face, kind of thing. That's the first thing. And this is going to be where we're going to set up the start location. So we're going to use an alt drag here, alt drag, to put it right on top of here, which is going to set the location of the start location of this line that I'm going to draw from the camera's location, wherever the camera is. Okay? Now, get player camera manager has two outputs. I can have as many outputs as I want. One of them, the other one is the get actor forward vector. So if I do that, if I say get actor forward vector, that means wherever the camera is pointing. Think about this as the normal. The camera's normal, which is pointing forward, right? It is a value of 1. It's a unit vector, right? Which means it only has a a magnitude of 1 unit. 1 unit means like 1 centimeter. It's pointing forward. That's what it is in Unreal Engine, right? What I want to do is I want to take this value and multiply it. This is our range now, how far I'm going to look, right? And we can physically actually have a second variable here. I'm not using it, but I could have an end location. That's the end location, right? But here what I want to do is I want to take this and I want to multiply it. I want to use a multiply node, right? You can press the star like this, multiply. And the multiply node, I can multiply it by a value. So right now it's multiplying by another vector. By the way, I can change the type I want. I can multiply it by an integer. I can multiply it by a float. Right now it's multiplying by another vector. Let's multiply it by a float. This is different than what I'm showing you in the PowerPoint, but you can multiply here by like 5,000. Make sure it's 5,000, not 50,000. So what this is going to do, remember multiplication with vectors, it'll take a floating point number and multiply it by each of the vector components, the x, the y, and the z. Okay, that's what it's going to do. By the way, if you don't like this because you're nervous, if you're a nervous person, you're like, wait, that's different than the PowerPoint. You could keep it the same. Okay, it's the same thing, right? All right, so now that I've multiplied it, what do I want to do is I want to add this to the start location. So I want to say that let's take the start location, press the plus sign, add, and then I want to add these two things together to come up with the end location. So this is the end location. So if I had another variable, let's add it, because it's not part of the PowerPoint, but I want to show you that we can do this. Add another variable. Let's call this the end location. All right? And if I was going to set it, I can just alt drag here. Here's alt drag, so that we have the start and the end location here. Now, I need to connect it to the execution pin, because whenever I set something, I need to do this in the execution, line of execution. I want you to think about the execution line as lines of code. Start location is the first line of code. End location is line of code number 2. So in C++, this is just 2 lines of code. All right? And if you think it's nuts, all this, that's what I'm saying. You have to decide, C++ or blueprints, right? Now that we have the start and the end location, and this is kind of what I'm doing here, right? Because I'm saying, here's my end location right here. I can just line trace by channel. Let's do that. So if I say line trace by channel, line trace by channel, here it is. I have a start and an end location, except, oh man, what did I do? Tom did a bad thing. He put these things. I can draw lines here like this, but that's really bugly. Here's the better thing we can do. Because they're variables here, we can just call them here. If I right click and go get start location, I can get a variable like this too with no line drawing. So sometimes you'll see a very complex graph, and we can make it simpler, right? Same thing with here. If I can get end location, here's my end location, there it is. So I've got these little 2 things, and it's much more descriptive here if I just do this. Look, start, end. And I can take these 2 things and make them nice. Right here, no funny lines being drawn everywhere, right? And here, I can kind of comment stuff. Like I put a comment here that's like, use the player camera manager to compute start and end location. That's okay, let's do that. So grab all these, and I can say, use player camera manager to compute start and end location, which is what we did. And if you want this thing to be black, like I like it, again, click onto that on the right. You can choose black. And then just save that. So I put it up here, so you can always have that right here. Choose black, press OK. Now my black comment is there, right? Back to this point. So I've made a line trace. Let's take a look at this line trace. I think it's important to know what it is. So line traces are this. It's a raycast, right? So I'm raycasting from start to end, and I'm looking at the visibility channel. The visibility channel, my friends, is the channel that is going to be the collision channel. If my visibility channel is not blocked, is not in a blocking state, I will never be able to hit something if it's not blocking the visibility channel. Okay? Do I want to trace complex? If I had a complex object, right, then I might want to use a complex way of tracing it. Let's say I want to hit a specific spot on an object, right, as an example. I can also choose actors to ignore, and by default, my actor to ignore is self here. So I'm ignoring myself, so I'm not going to hit myself. That's the important thing, okay? And then I can also draw a line as a debug line if I want to. For now, we're going to do that. We're going to say draw for 1 frame, right? Here's 1 frame, so we can see what we're drawing, right? Here we go. And then what I want, we're going to turn this off later. And then what we're going to have here, if I look down here, you can see that the trace color and the hit color, if it hits something, it's going to be green. If the trace color is going to be red, right? The red line is going to show up. The draw time, how long it takes to draw, is going to be there. And so you have a built-in debug, which is what we want, right? On the right, there's an out hit, and there's also a return value. The out hit, oops, undo. The out hit, notice, is split into all this. We can break the hit result instead of splitting it here. So if I right-click here, I can certainly split the struct pin. But if I did that, it's going to make a huge list right here. It's going to make this node pretty large, right? Or if I drag off of it, I can break hit result. Notice that is an option, break hit result. And then it becomes much smaller, right? It's not like it's not like permanently open, put it that way, right? So the break hit result was interesting because I can open it and collapse it. These are all the items that would have been added here, okay? And what we need is a couple things, right? We need the impact point. This is where I'm hitting, okay? So that's the location of what I'm hitting, okay? That's what the location. And I want to return this out of this function. To do return anything, we need a return node. So I'm going to right-click here and type in return node. There it is. Add return node. Okay, and then connect those. And here's a really quick way. I could, on the right here, manually put the type out here on the right-hand side. I could do that when I'm clicking on the return node. I could do that. Or I can take the impact point and I can drag it on top of this return node and it'll make it for me. Okay, nice and easy. So here's the impact point. It actually added an output. You can add more outputs if you want to. I can add as many outputs as I want here, right? And I can also delete these outputs the way I want. I can add outputs manually or automatically. Same thing with inputs, right? And now we have our first version of our function. This is the perform line trace function. Compile and save. All right, so we've added a few functions. It's a great place to put it up on DevOps. So again, git add dot, git commit -m, and we'll say added functions to support firing. Realistically, what could we have done? Every time we added a function, commit. Okay? Git push. I'm just showing you the minimum amount of commits that would be acceptable. All right, so now that we've got this, we've got our functions. This is great. I was going to take a break, but we're 10:19, and I'm afraid I'm going to go overtime again because of all the stuff I got to do with you. So we've got all these functions. Notice that they appear here on the top. So we can collapse these. We don't have to see them all, so they're not there. We also have under functions, if you look at functions here, they're kind of in the wild, right? We could put them under combat again. So if I click on the function itself could also go under, category for the function. So all these are different functions, right? And a couple things for functions. One of them is the access specifier, right? Which is, are they public functions that can be accessed outside of this blueprint, or are they public, or they're protected or private, right? And the category is up here. So notice that there is combat already, because we already made the combat category, right? So we can add those functions in to the combat category, so that way they're organized. So if we want to do other kind of things in the future, we can save that, and it would be in a different category. Compile and save. Wonderful. We have those functions. And now we want to add in our IA fire event. Let's do that. So right click, IA fire. And under the IA fire, we have a couple things we can do now. And let's take a look at that in the PowerPoint. So, oh yeah, did we miss something? We missed something. Spawn impact particles. Let's do this one next. Sorry, I forgot that one. See what happens? That's why I have PowerPoint. I'll be like, hey, wait, what about the impact particle? Spawn impact particles. I'm going to grab this copy, and this is a really simple one. Again, I'm going to go back to here, and I'm going to add a new function. So a new function, we'll say spawn impact particles. Immediately I'll put it in the combat category so I don't forget. And then spawn impact particles is going to actually do, take the impact particles, and it has a location, right? So the spawn impact particles actually has an input. Notice that? It has it there. I didn't specifically say it does in the PowerPoint, but it does have an input, location. If you ever see this in future PowerPoints, you know that there's a location vector that is an input. So how do we do that? If I go back to here, if I click onto it, I can go here to inputs, and I can add in a thing called location. So where am I going to spawn? And then in here, I can choose a vector location. There's the location right now. So there's the location. Okay, I added that in here in the inputs, right, manually. And then I want the impact particles. So impact particles, again, is a variable over here. I can pull that in. Here's get impact particles. And if I want to get the location, instead of dragging a line, I don't want to do that. I can, again, just type get location. And if you look at the bottom, you can see that get location is a variable that I can use that I can have in here. And notice that Unreal Engine 5.54, by the way, 5.44 last year didn't have this little thing. This means it's a function variable. That's what this little mark means here, okay? A function variable. And then what I want to do is I want to spawn emitter at location again. So again, I want to go back to Unreal Engine, and I want to right click, and I can just, let's type it like this, spawn emitter at location, right? And again, I want to use a line of execution here. So the execution pins. I want to have the emitter that I want to create, which is an emitter template, this one, impact particles, and I want to have the location. There we go. So that is spawn impact particles. Okay, sorry about that. I should have included that before I did the push, but that's okay. Are you with me? Again, all of this should be pretty good. And if you're looking for where I got location from, just type get location. I remember I added it in. If you don't have this already, look, you won't get it unless you add it in as an input first. So on the right here, click on this, and on the right here, I added it in as an input, and then I can get it. Okay, has to be a vector type. I did it because I didn't want to do this, guys. I don't want to do this in my functions. This, I don't want to do that. That's ugly. Okay, I don't like doing that. It's an ugly thing to do. Instead of doing that, I just get location, and then you don't have to do that. It's an ugly thing. You will never see me do that in my functions as much as I can. Okay, compile and save. And now let's go back to that event graph. Okay, so now that I've got this, I've got all the piece parts I need, and I just want to do this. Isn't that a beautiful thing? So when I start firing, I want to play the muzzle flash, I want to play the weapon sound, I want to perform the line trace, and I want to spawn impact particles. Let's do that. So again, I want to, right? I want to play the muzzle flash when I started, right? I want to play the weapon sound, that's next, in sequence, right? Here's play the weapon sound. And then I want to perform the line trace, right? And I want to, kind of spawn the impact particles, all in that order that we just did it. And now the one thing to do to spawn the impact particles is I got the impact point from the perform line trace, and I want to just join these two things together like this. Okay? And that is my IA fire function. Okay? Let's test this and see if it works. So if I go back to here, and then if I go here and fire, notice that I see, for 1 second, I see that line. That's a red little dot. You should also see the same thing. Okay? If you see some weird ass particles coming out, that's because they need to be fixed. You shouldn't have that problem. If you've loaded things in properly inside of your stuff, then those impact particles won't look like that. Okay, if somehow you didn't do what I did when you imported the weapon, then you'll have a weird thing. Instead of this, you'll have like squares that come up, right? And those squares are just textures that are billboarded to your face, so they look like they're a big square, but actually the texture has a transparent background, and you're supposed to see nothing. You're supposed to see none of that stuff. All right, so we did that. We know it fires. We know where the point of fire is. And what I did was earlier, I went to the perform line trace, and in here I said for 1 frame, right? Well, you can actually draw it for duration. So I can say draw it for like 5 seconds. Let's try that out. So if I did that again, and if I go here, and if I draw for duration, then you can see a line where I'm drawing from, like this. And if I kind of go over, you can see that those are the lines coming from the player's camera, right? So those are all the places I fired from, right? And you can see that they're going to last for 5 seconds and then go away, right? Notice that I didn't get any green lines. They're only red lines because the floor does not block visibility. It doesn't block the visibility channel. Because it doesn't block the visibility channel, I don't have an actual hit. I have a hit from something else. It'll block me, but it won't be the proper hit that I want. That's why it's red, right? When it's green, it means it'll block the visibility channel, which is what I want. This is great. I've got firing. Let's put this up on DevOps. Added fire, IA fire event. All right, so we've prototyped it, right? So now I'm confident you guys can do it all in C++, right? It's not so easy, my friends. And I'm laughing because there's lots of steps to figure out here, right? Yeah, he's looking at me like, what, is he crazy? Right? And it should be. You should say that. You should say, he's crazy. That guy's crazy, man. My professor is nuts, right? He's like, there's no way that it could happen. Okay, we're almost there, guys. We're almost there. Let's make the drone now, adding the drone. So the drone is another character, right, is what we need to do. And so what I want to do is I want to reorganize stuff. I want to put a new character folder, and I want to drop in animations, and I'm going to drop in all this stuff in here inside my character folder. Let's do that. So back to this. I want to go back out to blueprints. I have all this. Let's make a new character folder. New folder, character. And I want to take animations that I have here and drag it into my character folder. And I also want to do the same thing with these. So grab these two and drag and drop it into my character folder. Move there. It's going to take a second. It's going to say, are you sure? Blah, 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 blah. Yeah, okay. And then inside my character folder, you can see it's really nice now. It's like, got this, right? And my content looks like this. It has assets, blueprints, input, maps, starter content. And I have in my blueprints, I have a character blueprint, a character folder. I want to have another folder called drone. New folder, call this a drone folder. Here's my drone folder. Next week, we'll do a little bit more of the drone. We'll actually make it move around and stuff like that. But for now, inside the drone folder, we want to add another blueprint for the drone. And the drone is going to be of type character class again. Let's do that again. So back to Unreal Engine. I want to add a brand new blueprint class of type character. And we're going to call this BP underscore drone. There's our drone. Inside this, right? Inside this, in the mesh, the only thing we need here is the mesh. And I want you to pull down in the skeletal mesh right now where it says Bellica drone. This actually comes from another set, Sergeant Bellica, actually. And for those people who don't have that, I want to see if my Epic Games Launcher works. Launcher, there it is. Just to point this out, I give credit to where it's due. Can I launch it? I may not be able to get to it, but give me 1 second. Epic Games Launcher. All these windows open. Epic. Can I do that? Can I open it up? Maybe. Maybe not. But if I did, let's actually see that. Maybe there's another thing because I'm not showing my icons. This one. Okay. Anyway, when you look there in my Epic Games Launcher, sorry guys, just look at my home so I can get there and I'll show it to you. It's important because I want you to know where everything's coming from, right? And then, sorry, oh, high quality color, and let's use the display, which is this one. Okay, Claude, thank you. But if I would look at my Epic Games Launcher at home, right, then you can see in my library that I have many projects, right? And one of them is, it comes from this really great game that never happened. If I scroll down. And Sergeant Bellica is the thing. So it's called Paragon. So Paragon was a game that Epic started, and they never produced it. They just killed the game, right? But they had these really great, things that you can download. So if you wanted to download Lieutenant Bellica, so this is the asset itself, right? And by the way, notice that it's not even available anymore to download, Lieutenant Bellica, right? But it is for me, because I had it way back there. See, it's not even coming up, right? Oh, there she is, right? And so that's what it looks like. It's a complete character with crazy stuff that's built into it. Or just amazing things inside of there that are really great, right? So one of them is this drone that it has, right? So that's what Lieutenant Bellica has. And that's why I grabbed this asset. And again, it comes from the Paragon, kind of pack, right? All right, so back to what we were doing. I wanted to show you that because, again, it didn't come from nowhere. It has this kind of really cool built-in, scrolling material, scrolling texture. That's kind of part of the material itself, which is kind of cool. And it lights up in a darker situation. This would be cool. Now, I've created this map, this test map, so you're not going to see this happen. The test map itself is going to prevent this from happening. And why? We just want to see it. We don't care about all the special effects right now. Okay? In another map, we're going to see this special effect come up really, really nicely, but not in our test map. Okay, so one thing we know is that when we enter this thing in, it's pointing in the wrong direction because this is forward. See, the X is the forward direction. So what we want to do is we want to rotate it across the Z-axis minus 90. Minus 90, like this. So it's pointing this way. This is the front of the drone, right? It looks like this. I'm not moving it across the Z-axis. I could put it higher up if I wanted to, but I'm using the capsule simply as a way of positioning my drone in a different location. I could also, one day, instead of using the drone the way it is right now, I could create my own asset to do this, but right now the drone just has this thing right now. Okay, that's the mesh. It's very simple. Compile and save. One thing we need to do is we need to change our collision parameters. And the way to do that is there's a capsule component that comes with every character. And if I scroll down on the right-hand side, you will see this collision profile right here, right? Here's a collision profile. This is important because this is one of the most confusing things in Unreal Engine, okay? Very confusing. It has something called a collision preset. Right now, if you open it up, it shows you a grayed out area of things that it will collide with. Notice that the visibility channel is ignored. We need to not ignore this channel. If it is ignored, then our shot that we use, our trace that we're using, our array cast is going to also be ignored. We need to make this not ignored. So there are a couple ways to do this. You can change this to something else that doesn't ignore it, or let's go custom. In the PowerPoint I did it differently, but all we have to do is change the visibility channel from ignore to block. That's all we have to do. Okay, ignore to block. That's what we did there. I also want to do this not just on the capsule component, but also on the mesh. So if you go to the mesh, so there's two parts, right? You can collide with two things. You can collide with the capsule, this part, and you can also collide with the mesh. All right, so for now we're going to do them both. Later on we'll talk about why the capsule is not really cool to do. Why is it not really cool to do the capsule? Visual collision will be up here, but it's going to collide. That's why, right? So logical collision will work, but visual will be like, wait, I missed it, but I got it. How did I do that? Because the capsule goes above the drone, right? And below the drone. So realistically, it's just the mesh that we need. But for now, we're going to do both, right? And we're going to go into the character mesh, and we're going to say custom. And again, what I want is to block the visibility channel so that it's going to work, okay? Compile and save, please. So now that we've got that, our drone is a viable target for our destruction, okay? And let's try this out. So I'm going to take this in and drag the drone, and I want to look where my player is looking. My player object is here, right? And this is where they spawn. And I want to kind of drag the drone over here. Here it is. And I want to make them point at our player, so we're going to rotate this by 180 degrees, right? So that it looks kind of at our player. There we go. And if I press play, then you'll see that we see the drone, and it's in front of us. And if I fire the weapon, right, then if I fire it on the drone itself, right, you can see I'm still getting red, but then after it becomes green. Take a look at that. See how it becomes red? It was red, then it's green. Watch. Red, but green. Green means, hey, you're actually detecting that you're hitting something that should be hit, right? That's what's happening here. Red means I missed. So even though the drone will be hit, how about up here? Look, even up here, because that is the capsule, and so is down here, right? Capsule is kind of below it too, right? So above and below it, it still works, even though we only care about right here, okay? I wanted to demonstrate this because so you understand how collision works. Collision is all about what you decide to turn on and turn off. And there's different levels. We'll talk about collision in more detail another time. Back to this. So we've done that. We've turned on the collision stuff. I want to make a couple of variables in the drone itself. The drone is going to generate some variables. One of them is the explosion sound, and the other one is the explosion particle. So let's add those in. So again, in the drone blueprint, I'm just going to kind of simplify this. I don't need the character, APP, FPS character anymore. I can kind of close that. I want to make two variables. So one of them is going to be called the explosion sound variable, right? So let's go back into there. Explosion sound. The explosion sound is going to be of type sound base. Sound base object reference, right? And then what I want to do is I want to select notice that combat doesn't come up here on the drone because it's only to the character. So I'm going to make another category called combat, and I'll put explosion sound, explode sound there, okay? Explosion particles is the other one. So I'm going to make a new one called explosion particles, and this is going to be F-type particle system object reference. So particle system, object reference, there we go. And that is going to be the explosion particles. I also want to be part of the combat category. There we go. And compile and save. Then I can look here in the drone itself. I can go back up to the top, filter for combat, and then I can have those two things. And the explosion sound is going to be an explosion cue. That's what I'm looking for. So I can kind of go down here and look at explosion. And if I go look at explosion cue, that's the one I want to use, explosion cue. We'll talk about other sounds later on, but for now, explosion cue is fine. And the explosion particle is interesting. It's called vortex grenade. So let's try that. It's from another character. So we'll type in vortex, a little bit, just vor is enough. And then there's the explosion grenade. Okay, so that's the explosion particles. So again, we've made our gun particles, but now we need to make what happens when the drone explodes, right? Okay, awesome. So we've got those two things. Next, for the drone itself, all right? We want to make a new function called play explosion. Okay, that's a new function. If I'm going fast, go refer to the PowerPoint. It has everything in there. Here's the play explosion, right? I just want to get through this. And then the explode sound is what I'm going to use. So here's the explosion, explode sound. And then I want to get actor location. This is the location of the drone itself. So this is going to be a different kind of sound. Get actor location. That's the location of the drone. Notice the target is self for this one. Get target location, right? And I want to play sound at location. This is the second type of sound that we have, all right? So we can play sound at location, all right? Second type of sound. This is a more expensive sound, right? Because it's going to have attenuation. The farther away this explosion sound is going to be, then the less sound it's going to make. Okay, there we go. So those are the two things. That's my play explosion sound. Right? And we're going to have another function. Again, this is right from the PowerPoint. We're going to have another function in there as well. And that function is going to play the explosion itself. Right? So play explosion. So I'm going to do that too. Play explosion as a function. There we go. Play explosion. And play explosion is not going to have any inputs or outputs. It's going to take the explosion particles and get actor location and spawn emitter out location. So let's do that. So explosion particles and get actor location, right? And what we want to do is we want to spawn emitter at location, spawn emitter at location. And we want to take this location right here, and we want to have the particles, and we want to connect this execution pin. And now we have the play explosion function. Here we go. I'm not going to turn on any funky anything else in there. There's other things we can turn on and blah, blah, but that's all we have to do. Compile, save. For the FPS character, one thing I also want to do is I want to go back quickly to my perform line trace and do two things. One, I don't want to spawn any more lines, so let's turn that off. So none for draw debug. This is in the perform line trace function. Okay. I just jumped to that for a second. I just remembered to do that because we turned it on and it's not part of your PowerPoint. All right, back to the drone. Adding the drone, we're going to continue. We're going to event damage. Let's talk about this event, any damage. Okay, so this is an event, a special event. If I go back to the event graph of the drone, not the player, the drone. Here we go. Notice that there's all this other stuff. The event graph of the drone looks like it's all grayed out like this. We can actually remove all this stuff. Take a look. I don't need any of these points anymore in the event graph, but I want to make a new event called any damage. Okay? This is a really cool thing. Unreal Engine knows that we're going to be doing damage to something. All right? It's a game engine. This is where I like it more than Unity. Unity, there's none of this. All right? You got to detect stuff. You got to write all this yourself. Here in Unreal Engine, it knows that you're going to take damage. So in the event that we take any damage at all, right? At all, any damage, right? Then what do I want to do? I want to play the explosion sound. I want to play the explosion, and then I want to destroy the actor. Now this is funky because if I destroy the actor before the explosion is played, I'm not going to see an explosion. So let's try this out. So if I go, first of all, play explosion sound, that should be in the combat category. So combat category. And same thing with the play explosion in the combat category. And so I want to play the explosion sound first. If I take any damage, right? Play the explosion. And then there's a funky node that you can add to any actor called destroy, the destroy node. By the way, this is exactly the same, destroy actor. This is exactly the same in Unity where you have destroy game object. It's exactly the same, all right? All right, so that way, if I take any damage, then I destroy myself. That's what this is saying. Otherwise, I'm going to play the explosion sound and the explosion itself. Okay, we'll come back to this, and we may disconnect the destroy actor node for now as we come back. Let's come back to this. I already did this part, which I said go to your capsule component and block all. But now we need to go back to the BP underscore FPS character and change the perform line trace so that it actually applies damage as well. Okay, let's do that. So back to FPS character, I'm in the perform line trace, double click. And you can see that I've got a break hit result, and I want to just stretch this out a little bit. And what I have in here is, I don't want just the impact point, but I want to apply damage. So let's add the apply damage node. Apply damage, here it is. So apply damage, we need to kind of inject here, like kind of put it in. So the way to do that again is you can kind of grab the execution node, go here, it disconnects the other execution node, and from here I can continue. So I've actually inserted this applied damage in between the line trace by channel and the return node. That's what I've done here, right? And we have this funky thing that runs through this thing. I'm just going to add another reroute node so we don't have to see that, so it doesn't block me. I don't like that too much for now. And what we do care about is that the hit actor is the damaged actor, the hit actor, right? So a hit actor actually comes from the break hit result, and I can just grab this and put that here. This is the damage actor, okay? The damage causer is self. I'm the one that's causing the damage. So you can get a reference to self. If I just type in self, you can get a reference to self. A reference to self is like using the this keyword, right? So this object is causing the damage, this one, right? And now you're going to see these like funky lines everywhere. You can kind of collapse these so it looks not as bad, I guess. But this is where the wires, you can move things around until you can see things right. Like I like it so that I see this. You can also add another reroute node here if you want. So it's like a little bit cleaner. And then you can move it back. I like being able to see what I'm doing. Okay, does that make sense? And this, notice I have to create some damage. Look, base damage is 0. Let's add in 1 damage. It does 1 damage, right, for base damage. So base damage is 1, okay? And compile and save. So now when I hit something that blocks the visibility channel, I'm going to apply 1 damage. The drone is going to listen for damage, and when it takes 1 damage, it's going to make the explosion sound and explode. Let's try this now. So save, play, and if I hit the drone properly, it should play, but it went away, like I said. What happened? Well, the problem with the drone right now is there's no delay, right? So the destroy actor node triggers immediately after it's been destroyed, play the explosion sound, which means the explosion sound doesn't have a chance to resolve without the drone being destroyed, right? We could put a delay in here, like a second or whatever to do that. For now, let's just undo it, uncheck it, so the drone will stick around. We just want to see the explosion, okay? So compile and save, and if I go back to this, and if I press play, then what I want to do is I want to explode the drone. That's what it should look like every time I hit the drone, right? Right? And that's what the drone will look like. So when I kill the drone later in the game, when we make it next week, I can kind of explode the drone, and that's a nice little explosion effect that'll happen every time. Are you with me? Cool? But I want to make it so that it doesn't get rid of the drone until it's been completely, it's been destroyed. And for that, we need some delay. We're not going to do that this week. By the way, all of this that I'm doing for you right now is for you to do. I'm doing your part, your job. I'm getting you to do the rest of the part for you, right? So we could have ended it like 10 minutes ago, but I want to step through it with you to show you everything. So because there's some pitfalls, if you will, that I'm trying to step you through. Okay, so if I don't finish, the rest is on you, but let's see if we can finish. We only have the HUD left, and there's some other points here that I have to make, and that's it, okay? So one thing that we want to do is we want to add we added the drone. This is pretty cool. And now we want to add a simple HUD. So how do we do this? A HUD is another class, and what I want to do is, if I go to the blueprint folder, let's stop this. I know I'm going to run over time, but bear with me, guys. I want to add a new blueprint class, and I want to search for all classes, and I want to type in the word HUD, right? And you can see that there is a HUD class that I want to add in, okay? And I want to call this BP underscore FPS HUD. Okay, so this is the HUD, the heads-up display for my first-person shooter game. Now that I have an FPS HUD, remember that I had my game mode. Remember game mode? Game mode had a default HUD reference inside of it, right? Which means if I go to my character inside my BP underscore FPS game mode, there is a HUD reference, and I want to select that HUD that I just made, which is BP underscore FPS HUD, right? Again, this is inside of the HUD, the BP underscore FPS game mode that's here. This one. So why did I do that? Because when the game loads, remember, this goes back to the the gameplay framework. Unreal Engine's gameplay framework has all this stuff that it loads in by default, unless you define your own game mode, which we have, right? Game mode defines the default pawn, which in our case is the character, and it also defines other stuff. One of them is HUD, which means what's the default user interface that I'm going to show up with right away, kind of thing. And that's what we've defined here in the BP underscore FPS game mode. All right, so that's the HUD. And once we have that, like I said, we've changed the HUD class. We did that part. And now what I want to do is I want to also make another user interface. and I need to put this inside, like here, I defined it inside of another folder called HUD. Let's do that. So let's make another folder. So we'll take it out of blueprints, and we'll make a new folder called HUD. This can also be called user interface or UI, and we can drag this in there. And then inside the HUD, let's make another user interface. If I go down to user interface, you can see that there is a widget blueprint. Widget blueprint. You guys do widgets yet? Widget blueprints? Oh, I'm ahead of Steve. This is great. Let's choose user widget. User widget, right? And it's so user blueprint, user widget blueprint. So it's widget blueprint, WBP underscore, right? And then we're going to say FPS overlay. Okay, so let me explain what a blueprint is. A widget is. Widgets, right, are user interfaces. And this is where I 100% like this way more than Unity's, all right? Unity has a canvas, right? Here we're going to add our own canvas, and we have way more control and way better user interface objects we can drag into this user interface compared with Unity. Unity is bare bones, right? Here we've got lots of great stuff that we can add in that is way better, right? So now that we've got our WBP FPS overlay, notice that I want to go in there. So let's double click in there. And when I open it up, it looks like this, like another designer. So here's the design view. There's also it also has at the top here, just to let you know, just a really quick tour in the last minutes of our class. It also has a graph. Take a look at this graph. So it has a graph, and it also has our designer. It has those two things. So it actually has its own event graph, which is pretty cool, right? So what we really need here is the basic thing we need is a canvas. So if you actually search for, on the top here, canvas, right? And you can drag and drop a canvas panel in here. It looks like this. Now this is really cool. Notice that the scale is up here. You can actually scale this canvas eventually to anything you want. For example, it'll scale nicely to a mobile screen. It'll actually scale to different devices because it's using a 16 by 9 scale. So it'll scale anything to 16 by 9, any screen, which is really cool by default, guys. Unity, not. In Unity, you have to define that it's kind of a relative scale. Notice also the parent class is user widget. That means one day, if we want to define our own, we would have to inherit from user widget in C++ to define it. All right. Now that we have a canvas, what I want is an image. Okay? If I go to image, I want to drag and drop it somewhere in the middle of the screen like this. Okay? Now there's a couple things to note here. The image has an anchor point, which is way in the top left corner, right? Just like it would be in Unity, right? The anchor point, if you look at anchors, you can decide where you want to anchor. This is very similar to Unity, right? For example, their transform that they have in Unity is a different kind of transform, remember? So it's kind of the same thing here. We're going to check this middle, so we can see that this is the anchor point for this this image. I'm just zooming in here so you can see the image, and there's the anchor point separately. And then it does the positions relative to the anchor point. Okay, that's what it does. So the anchor point itself, you can see, is 100 by 40, right? And the position that we have here, let's put this position. So there's a couple positions here. There's position 0, x, and y, and there's also the minimum and maximum of your anchor. So if I open up the anchor, you can see that 0.5, 0.5 is what it should be. That's this, right? And then position x and y should be 0. Okay? There's a position x and y. So that's kind of right in the middle. And then there's alignment. Alignment is down here. Alignment is 0.5. That's halfway in the middle of the canvas and halfway relative to the canvas stuff. So it's directly in the middle. That's where that image goes. So I've allocated all that. In the brush area, that's where you can define the image itself. So I can choose reticle, first person crosshair is what it's called. First person crosshair. And it's kind of skewed, right? It looks like this, but we can choose size to content. That's a checkbox we can put up there. If you choose size to content, then all of a sudden it becomes the right size for a screen. There it is. Okay, that's the reticle. Compile and save. And again, we can call this crosshairs if you want to be very specific, crosshairs. Right? And it's just a name that we can give it so that we can reference it if we want to later. One more slide. Now, all we need to do is in our FPS HUD, we need to create an overlay and add the HUD to viewport. So again, back to our save, compile and save. Go back to our BP underscore FPS HUD inside the HUD, the one you just made, right? And in its event graph, then we don't care about these, but we do care about the begin play. When the HUD is created, that's what this says, right? What do I want to do? I want to create a widget. So let's do that. So we just type in create widget, right? Here's create widget. But notice that the construct says none, right? Because we have to specify the widget we want to create. In our case, we want to create the WBP FPS overlay. So this creates the widget. This instantiates the widget. We just made it. This is really cool because what we can have is we can have multiple widgets, multiple user interfaces, but that we layer on top of each other, right? And so this creates the widget that we want. In this case, our reticle, right? Now we want to add this to viewport. So if you go to the return value, we can say add to viewport. And then once you have this, my friends, you have your reticle. You have your reticle. Okay. And if I press play, take a look at what we have now. We have a reticle right here. And that's where we're going to fire every time. Right? But we have a problem. When I aim, my reticle is like messed. Your job, which is part of your in-class exercise 3, is aligning your gun so that it looks like you're aiming at the reticle. That's your job. I want you to take that yourself, okay? I've done 90% of it, 99% of it. This part is yours to do, okay? It has nothing to do with programming. It has everything to do with art. So if you're a person who is like, to think about how to do things in three-dimensional space, let's do that. But for now, let's put this up on DevOps. So we'll say git commit -m, and we'll say added drone. We did a lot with the drone. We could have made many more commits here, many more commits. Like we added the drone, we added the thing, we made the functions, we did all these things, we added the user interface, lots of stuff we did, and we didn't do that. I just did it all at once, right? Because I'm running out of time. So this is my stuff. So how do I change that? Hints about how you should continue. What do you think you should do to change that? To align the the gun that we have. So here's my viewport. Right, here's my gun. How do I change that gun? Look, it's like aiming up already, and it's aiming like way over there. How do I change it so that when I'm aiming, right, then what do you think is a good thing to do? Yeah?
Rotate the grip point.
Could do that. I recommend a couple things before you rotate the grip point, okay? And here's some things for you to do, for you to try. Move the gun. It's a little bit too close to the person's eye as it is. It's here, like it's in the person's eye right now. Move it out a little bit so the gun barrel doesn't go into the character. You don't want to see the shoulders because that's too much, right? Because you probably won't see your shoulders when you're firing your gun, right? But the gun itself is too close. It's inside the camera. So I recommend moving it out a little bit, okay? That's the first thing. So that means that take the arms themselves, the actual mesh of the arms, right? And use your little controls here and just bear with me, right? Again, very, very gently move your controls so that it's out. Now notice how it snaps, right? Like way out here. Let's undo that. You could uncheck snapping. Snapping is right here, right? So you can uncheck snapping and you can uncheck alignment, right? Uncheck these two things, please. So that way in here, you can gradually move here, like micro, updates. So if I do that and if I press play it right here and see what it looks like. You can see now that the gun is like here, still kind of, this is the first thing I would do. I would move the gun out a bit more even, right? So again, I would move the gun out even more, right? And then it's a little bit better. Look, it's already better, right? Because it's like kind of outside of the person's can. I'm not seeing the whole gun, right? Let's keep on doing that until it's extreme. So here's the extreme example, right? That's wrong, right? So if I did that, And if I did it, now you can see that the shoulders are there, right? So it's almost like I'm never gonna not see those things, right? There's ways we're gonna fix this, but that's way too far out, right? That's way too far out. So again, you can see it's something like that, where you don't quite want to see the shoulders, but the gun is going to be, you don't want to see the gun either. So when it's like abutted to your shoulder, right? So let's see what that looks like, right? That's probably the limit of where you want to go. I don't want to go further out than that. That's the first step. And then, now start, like what you said, start aligning your gun. How do I do this? The way to do this is trial and error, right? But the way to do this is do it here. Right? So, again, right, the grip point is what you want to change. Right? You've done the macro alignment. The macro alignment means that the person's shoulders are making it so that the gun is so close to the camera. And again, from a camera perspective, you can see the field of view right now is 90 degrees, right? And if you go to the frustum itself, right, here's the camera mesh itself. If you look at the lens, there's like a lot of details, that you can look at, So take a look at some of these things. Is there a way that I could reduce the frustum? Because right now, look at the aspect ratio is this. That's perspective mode. Is there something I can do, to kind of reduce, how close I can see up close, where I'm not occluding my stuff? So I want to kind of give you that to look at, a little bit of homework for yourself to look at, right? That's the camera. But in the gun mesh itself, if I double click the gun mesh, and not the gun mesh, sorry, double click the arms mesh. So double click this, and I bring up the arms mesh itself. And if I go back to the preview scene, and if my preview scene is a reference pose or use a specific animation, and I want to choose aim, I think aim idle might be the best thing to use, right? So aim idle. Here's aim idle, right? And now you can clearly see that if I stop this animation, you can clearly see that the animation is like aiming upwards. Also, you can clearly see that this is not correct. So this is like, kind of out of alignment a little bit, right? You want to put this inside the person's grip. So what you do is you go back, like you said, go back to the grip point, right? And what you want to do is do a couple things first. First, let's align it by, so that the gun is sitting inside of the person's, hand. All right, so there's a bit of adjustments to make. So something like this. You can also look at it from the top. So perspective, you can go to the top, perspective. It's kind of hard to look at. That's the left perspective. Let's go to the right. So you can actually look at it from different perspectives so to see what it looks like as well. But you can also look at it from perspective mode. And again, it requires some trial and error, right? But to get that gun in the right position, like zoom in, like right in there to see what you're actually seeing there. So that looks a little better, but you can see here that the grip is wrong and probably should be something like this so that, the person's gripping is not like occluding their grip. Again, I'm just looking at grip point. You guys do it yourself. You can, all I'm doing is adjusting the position first. Position is first, right? Something like that. Let's see how that looks. And now I need to adjust the rotation because the rotation's off. So then I can adjust the rotation. And again, I want to rotate just a bit to there, right? So a little bit of rotation. And you see how off this is in a second, right? Now that I got the rotation and the grip point, that looks like a little bit too much. Maybe I want to pull that up a bit, right? So I want to pull that up just a touch, again, by eye, right? So that looks a little better. And now I have my gun kind of in a better position from that perspective. But it's too high up, I know that, so let's angle it down. I know that that is a thing to do, so I'm going to angle it down like this. Something like that. Now let's see what that looks like in game. So I'll go back to here, and then if I press play, now you're going to see that the gun is better, right? But I need to do a few more adjustments. So here's something that I recommend you do first. Macro adjustments, right? Make sure that the reticle, see how the reticle is off? Take a look, guys, right? Well, the reticle is going to be off, but I think the whole arm system has to move to the left, my left, until, I don't know if you can see this, but you see where it has those little marks in the white. See the white part on the gun, on the back, right? That little white part that shows little, like almost like a grid or whatever. That grid mark and the reticle itself, the aim point, the thing that you're aiming down the sights should be aligned with the back. It's not aligned right now. So the first thing to do is we're going to move this kind of towards the left. So again, towards the left means I want to move it, the whole gun towards the left, just micro amounts. See how that looks. Play again. And so now it's better. I want to get that aligned first because the gun is aligned properly, but we need to do it so that it's a little better. And I'm talking about the reticle. Look at that reticle. See how the reticle is to the right now? We want to go more left. We want to move to the right because we're too much right. The reticle is to the right. We want to move, again, in that direction. We want to move towards the right. So the reticle is kind of aligned properly. So again, towards the right is this way. And again, you can also look at this from a numbers game perspective. Like you can see that the thing that's moving is the y-axis, right? So here we're at 0.5324. Let's put it as like negative 0.54. And if I was to play that again, what does that look like? Right? So kind of better. Maybe 0.5, maybe 0.6. And let's see how that looks. Still more. And I'm not sure if you know what I'm looking at, but the idea is that you want to 0.5, 0.6. Let's try that again. That's way off. Let's try that again. Let's make it so that it's towards the other way. Until you get that aligned a little bit less. So again, micro positioning, like really small. No, it's too much. There. That's good. Now notice how it's the reticle, the red reticle is underneath the white marks on the gun. Now we can do alignment in the gun itself, where we can change the angle. And that's in the mesh arms. Back to the mesh arms. Now we can align it, right? So this has to be pulled back a little bit this way, I feel, something like that. And again, if I go back to this and do it, you can see how now it's starting to align. Let's do it more. Back to this. And then until, this is why it takes time and effort to do that, until you get a better alignment. Oh, no, that's too much. Undo. Control Z undoes. 0.1. Way too much. Maybe that. 0.4 difference. Almost. Let's try that. More. Ah, look at that. Look how good that is, right? That's pretty good. Maybe a little bit more. A little bit more. 0.1 would be good. Or under 0.1. I'm looking at the number here, 1.3, 0.13. That's good. And you can do that numerically as well. If you want to do it like by the numbers, that's better. Look at that. That's way good. Okay. Now, my arms are too high up. They need to go down, right? So my arms, so the reticle is right at the bottom of that U, where it kind of forms in my sights, right? So these arms have to go down, the physical arms, not the gun, right? So again, I want to just drag this down so you can see it from the side, so you can see what this looks like. I want to drag the arms down a certain amount. So I want to kind of drag it down, so 104, maybe to 105. Let's see what that looks like. More. 107. Now it's a matter of angling the thing. It's there, but now I have to angle the gun down because it's still pointing too high up. I don't know if you noticed that. Look. See how the thing is too high up now. So I want to put the gun down And this is going to require me to move the gun up a little bit. I'm going to move the gun up and then angle it down. That's what I'm going to do, right? Because it's already too low in the person's hands, right? So I'm going to move it up. And then I want to angle it down, right? So again, it requires some micro adjustments. Okay, back to this, try it out. Did I mess it up? Nope. More. 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 Right. Maybe too much. Let's see what that looks like. Nope, even it can take more. I know this is like watching paint peel, but it's very close. Look at that. It's way better, right? From that perspective. And again, all I'm doing is adjusting it, adjusting the arms until we get to a really good spot where it's not quite there yet. More. Till you get to, that's pretty good. Look at that. Okay, now the arms got to come down a little bit more. My arms. That's how it goes, right? So my arms themselves, these arms here, have to come down even more, and just a slight amount. 107.41, 107.82. Let's try that. Oh, look at that. It's almost perfect. So that's 107.81. Let's make it to minus 108. That's my number. And let's try that again. That's good, guys. Look at that. So now where I'm aiming, I can even go a little bit lower, like a little bit angled lower on my, because my sights in the front shouldn't be so high. So I can probably angle lower now on the mesh arms. Just a touch. Like we're talking about 0.3 difference, or 0.2. That's 0.2 difference. Let's see what that looks like. Yeah, look at that. Maybe a little bit more. More. 0.2 last time, so let's do another 0.2. 0. Come on. Maybe that's too much, but let's see what that looks like. 0.33 more. That's pretty good. Okay, now we need to move it over. The arms need to move over to the left, just a touch, right? I know this is crazy what I'm doing, but guys, this is what happens in real. And if you're making a shooter game, you need to have your reticle aligned properly, or else you're going to be like, wait, that's off, right? And your players are going to be mad, right? So, by the way, there's an automatic way to do this too, but I'm not going to tell you about it. Because I want to make sure you understand how to move things around, right? So you're better at it, right? So, okay, so yeah, so we need to move the reticle. So if I go and play it again, so if I'm looking at the left, I need to move it just a little bit to my left, a touch. So the arm's to the left. So that means this way. So that means to the right. So again, I'm just going to move this to the right. And right now it's like negative 0.2991. And I move it to the left, negative 0.392. Let's see, it's probably too much. Yep. So I'll undo that. Negative 0.031. We'll try that. 0.31. Let's try that. To the left, a little bit more. 0.035. Uh, 0.04, negative 0.04. Is that too much? Nope, take more. Negative 0.05. Almost. Negative 0.06. Let's try negative 0.08. Look at that. Negative 0.1. 1.2 until I get it right. That's good, guys. Look at that. So wherever my reticle is, that's where I am aiming now. And if I fire here, or if I fire here, I'm accurate. Okay? That's what I want you guys to do. That's all I'm going to do. But you saw the things that I was doing. Couple adjustments that you could make if you're really a stickler, if you're an artist, is check what the gun looks like in the person's hand. Is it like fighting? Is the texture like kind of like interacting with the person's hand? It looks pretty good, guys. Take a look. It's not so bad. Like I did a pretty good job in terms of putting the grip in place and all that kind of stuff. So now you have a pretty good setup for the gun. Okay. Questions around this? These things that I'm showing you, they're not exactly programming, all right? But these things that I'm showing you are things that you guys need to know, right? Even as developers, you need to know that something is off. If your artist gives you something and it's crap, you need to go back to the artist and say, it needs adjustment. I made it work, it's functional. You need to figure out, you need to kind of align it better because it's off. It doesn't look right, or whatever, okay? All right, so let's do that. I'm going to put this up on, I'm going to save all, file, save all now, and that's it for today. Sorry I went over time again, but I try my best with our little kerfuffles. And let's just do that. We'll say git add dot, git commit minus m. We'll say adjusted gun to work with reticle. There we go. That's my last commit for today. Okay, last thing for you guys when we look at this thing. Okay, so this is your in-class exercise 3. This is due tomorrow at midnight to make it work. You don't need a video for this. We did most of it together. Okay, so that as long as you follow along, I mean, even the PowerPoints will take you 99% of the way there, right? Like there is everything there. If you're attending class and you did this is good. One thing that I have is a challenge for you guys. Here's a challenge. Your in-class exercise 3 is what we just did, right? But, question, can you convert this into C++? And what are the steps that you would take? What is missing? What do you think that you need to do to make this work? Does anyone have an idea before we go? What do I do? I know it's a lot. But what do you do to make this work? Because you guys are going to have to do this for your game, potentially, right? So what do I do? What do I do here to make this work in C++? What do I need to convert? Well, here's the thing that I'm going to point you in the correct direction, okay? First of all, remember in C++ what we did. In C++, we defined a bunch of actions here. Input, input, input. So that is definitely something you have to do. You have to define all your input actions here in C++, right? And then map them in C++, which means on this side of the house, where you go down here to the input mappings, you have to map or bind your actions here in C++. That's the one thing you have to do. But we have a problem. Because in the blueprint itself, if you want the same interactions with what we have here, I'm just going to kind of close this down. Take a look at what the blueprint in the event graph tells us to do. We have all these functions, right? These functions. So this IAAim requires us to get a reference to is aiming from the anim instance, right? Here's the anim instance. We need to get the is aiming variable. Wait, we have no access to blueprints from C++. So that is a problem right there. How do I get access to that instance that both are going to share? We need to create another class of type anim instance, right? Which then the ABP blueprint, FPS blueprint, this one here, the, where is it here? The ABP FPS blueprint, this one here, it inherits from our custom class. It has to do that, right? And inside that custom class, because we've defined variable names already called is moving and is aiming, we have to make other variables to transition. We're going to migrate to C++, we need to make other variables. We can't have the same name as those because they'll clash, right? We can't have the same names. C++ and remember, and blueprints can interact with each other. If there's a variable that exists in blueprints and a variable that exists in C++, they will crash. It can't be the same name, okay? So what we need to do is make new names for variables. Maybe something like character is moving and character is aiming. Those two variables in C++. And it has to be part of the class, which is of type anim instance, which this class inherits from. Then, in here, we have to change all instances of is moving and is aiming to character is moving and character is aiming. We have to change all those instances in here so that they're aligned with that. Then, after we do that, once we've done that, we've got that class, then the next part is all these special effects, right? So, for example, the special effects that are here, like we've named muzzle flash, weapon fire sound, and impact particles, we need to make these available in C++, which means we have to forward declare a particle system as well as a sound base, U sound base, U particle system inside of C++. We have to forward declare those and make it so that we can map them and have to have different names. It can't be muzzle flash. It has to be like, I don't know, rifle muzzle flash and rifle weapon fire sound and rifle impact particles, something else, right? And then we transition away from using these variables to the ones that we have from C++ in here, right? That's what we'd have to do. So those things. Then we'd have to also make our own burst point, a physical burst point that is not here because burst point only exists in the blueprint side. It doesn't exist in the C++ side, which means we'd have to make a static mesh called, I don't know, something like a muzzle, flash point. Maybe we'll call it flash point. Flash point, which will be on the C++ side, right? And we'll replace the burst point with the flash point inside this. But that means that we need a reference to the gun mesh because we don't have a gun mesh in C++ either, which means we have to add two things, a gun mesh. Well, maybe we won't call it a gun mesh, we'll call it a rifle mesh, and the flash point, which is parented to the rifle, the rifle mesh. Then we can decommission our gun mesh and burst point and change those references on the blueprint side so that they use rifle mesh and flash point instead of gun mesh and burst point. You see where I'm going? Lots of changes, right? But we're halfway there. So if you want to try it, it's not impossible to do. It just means you need some research. You need to do a little bit of research. And the question you're going to probably ask me is, Tom, will you show us how to do this? Yes. But it won't happen for a couple of weeks still because we got lots to do. Okay? Hopefully this was instructive. We did our first part of our shooter. We can't shoot without gun, and we can't shoot without some kind of crazy explosion effect and a target like a drone. We did all that this week. Next week we'll make the drone move, and eventually the drone will fire back at us. Okay? Guys, thank you so much for this, and hopefully this is good. In-class exercise 3, again, is due tomorrow night at midnight, and you should have everything you need from my PowerPoint slides, for the most part, to get it done. Okay? Thank you. I'll stop recording now.